Bom dia.
Bom dia.
Good morning.
Good morning.
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 Hello. Good morning. Welcome everyone to the second day of the online pitch. I think all of you were here yesterday, so I won't do the same introduction, and we can go directly to the first pitch of today. We have again 20 startups today, and we're gonna finish the day at 1 Lisbon time, 1 p.m. So yeah, let's go. João, you can send the first startup in, which is GridStore Energy, and we have Garth and Michael. Hi, Garth.
Hey, how are you, Margarita?
Good, good. Welcome to the pitch room. You're with Michael there. Okay, yeah. So we are here with EDP and we are ready to hear your pitch. So you can go ahead and share your screen and you have 4 minutes to pitch.
Sure.
Yeah.
No worries. Thank you. Okay. As the world looks to renewable energy to mitigate the worst effects of climate change, there are two problems that are slowing that transition. The first is the visible and negative wholesale pricing, particularly in the middle of the day when domestic and grid-scale solar are at maximum production. In Australia, a leader in the penetration of domestic solar, this has made new grid-scale solar almost unviable. The problem's become so bad that in September last year, the average wholesale price of power in Australia was negative for an entire month. The second, unseen issue is the amount of power, up to 15%, that's being produced but unable to be exported to the grid due to unbalanced solar panels and unbalanced strings of solar panels. Solar Boost is the only product in the world to solve both of these issues simultaneously for less than the cost of an equivalent grid-scale battery. Like everything we do, our solution is simple. We install a modular, retrofittable 1.5 kilowatt-hour smart battery, wired in parallel under every solar panel. This allows us to do two types of balancing, one at the individual panel level and one at the string level. At a panel level, Solar Boost allows you to balance the current of each solar panel, as seen in this diagram. If you look at the top right-hand side, the panel is the lowest producing one in that string. Now with Solar Boost, the excess power produced by the remaining panels, shown in green, is charging to the Solar Boost battery instead of being wasted as heat to the lowest producing panels. At a string level, Solar Boost allows you to balance the voltage of each string going to the inverter, so that the lowest producing panel amongst all of those strings doesn't become the limiting factor of your solar farm's performance. And it's the combination of both of these types of balancing that can give you up to 15% more power from your existing solar panels, which last year in Australia was worth about 30% additional net profit. The smart controllers also allow you to see in real time the power production of every panel in your farm, allowing you to optimize the performance, revenue generation, and undertake preventative maintenance. So what would our pilot project look like? Ideally, it'd be over 2 sites, a new solar farm to demonstrate the economically significant gains that can be made even with new solar panels, and an older one to allow us to show the large gains from older panels, which have greater variations in power. The projects themselves are quite simple. First step, we'd look to data log several strings to find the lowest performing string in a solar farm and then install Solar Boost on it. We'd then data log the Solar Boost string and the ones in front and behind to provide real-time comparison data between the Solar Boost outcomes and the control strings. We estimated it cost about €30,000 to do 2 sites, with about half of that cost being for the Solar Boost batteries, which can be reused on any subsequent installation. Total project time would be around 2 weeks of preliminary work, plus installation and the duration of the trial. And the only thing we'd need from EDP to undertake the pilot, other than money, is technical assistance and independent verification of the results. We're also excited to announce that we've just added Jay Manley to our multi-award winning engineering team to work on the pilot. Jay's recently rolled off 8 years at Tesla as their critical programs manager for energy design engineering, where he was responsible for optimizing the engineering of Tesla batteries. So why Solar Boost? Solar farms are increasingly in need of energy storage to be economically viable. Solar Boost provides that energy storage at a price less than current grid scale options using lithium iron phosphate cells. It gives you up to 15% more power and 30% more profit from your solar panels and provides real-time monitoring of the performance of every one of those solar panels. So why should you choose a pilot with us? Because we think after the pilot, the world will be saying, why wouldn't you use Solar Boost for your next solar farm? Thank you.
Thank you, Garth, and thank you for keeping the timing. Okay,
we worked a long time on that one.
Yeah, so now let's go for the Q&A. Who has questions for Garth or Michael?
I'm here too, yes. Yeah.
Hello, I can start with one, and thank you for the presentation. On the pilot proposal that you were suggesting, are you limited by sites in Australia, or it can be elsewhere?
No, look, we could do elsewhere. We were just trying to give an idea of what the cost would be, and we chose Australia because it makes that easy in the sense we're not rolling in travel costs and everything, but it could be anywhere and any size. We just picked the smaller size being one string that we could do it with.
Okay. And then regarding your equipment, how do you typically manufacture them? Is it in Australia with suppliers that that you already have arranged? How is typically the process?
Yeah, so we've got two outsourced manufacturers that we work with. So we'd be getting the parts in, we do assembly here in Australia, and then we'd take them to wherever. So if we were doing the trial in Europe, we'd then take those with us over there.
Okay, good. Very last question on my end. For a project, let's say a 100-megawatt solar farm, how do you think that the cost for each one of these equipments paired with each solar panel would be on a 100-megawatt solar farm?
Yeah, well, in a 100-megawatt solar farm, there's effectively no limit of size that we can go up to. So we typically install a 2-hour battery or a 4-hour battery, and there is an option to install a 24-hour battery. As well as that, we're typically 5 to 10% less cost than what current grid scale batteries are on the market.
Okay.
And it's a plug and play installation, so the install time's a lot quicker, a lot simpler than AC coupled or even DC coupled batteries.
Okay, good. Thank you.
I have a question too. What is the lifetime of the Solar Boost?
Solar Boost is designed, it has a 12-year warranty, and it's designed to last more than 18 years for your batteries.
Okay. And how long it takes to install the Solar Boost? You comment that is easy to install, right?
Yeah, because what it is, under every solar panel, you have your MC4 connectors, which are very much plug and play. So our boxes of Solar Boost batteries are installed underneath the solar panel and literally plug and play into tapping into where the PV cables come out of. So it is very quick to install, and then it's just commissioning after that. So it's installed by just, for example, one man can carry that Solar Boost and place it in store.
Okay, thank you.
In the trials that we've done, it's taken less than a minute to actually do the connection of the Solar Boost. So, and then it's just where you affix the box after that.
And one of the end games for the Solar Boost is, when you think about it, you have climate change, we've got solar being one of the best ways to mitigate climate change, and now solar becoming unviable. You have all these solar panels installed, but they're generating power mostly when you don't want the power. So it comes to the point where every solar panel could be manufactured with a Solar Boost at the manufacturing time, so that they could be supplied as a single unit. And that's the end game where we'd love to see this technology end up.
Hey both, thank you very much for your pitch. What is your track record so far? You commissioned this to other companies? How many pilots?
No, so we're at pre-production model stage. We've actually just agreed today to a commercial trial with an Australian and European-based renewables company. So we've got probably about 4 pilots in train, but we don't have anything commercially installed yet.
Okay, thank you.
Okay, that's it. Time's up. So thanks a lot, Carl and Michael, for your pitch, and we'll let you know the results in the next few weeks.
No worries. Thanks for that.
Thank you.
See you all.
Thank you.
Bye.
Bye. Okay, so next, we had LAVO on the schedule, but they had an issue. We are trying to see if we can move them. So the next startup is Endua, and it's gonna be Paul. Who's going to pitch? So, João, you can let Paul in. Hi, Paul.
Good morning.
Good morning. Welcome to the Energy Starter. We are here with EDP, and we are ready to hear your pitch. So you can go ahead and share your screen, and you have 4 minutes to pitch. Yeah.
All right, making sure everyone can see it. All right, thank you, everyone. I'm Paul Cernia. I am the CEO of Endua, and today I really want to focus the discussion around distributed solar generation. It's a fast-moving segment in the decarbonisation of global energy systems, and it brings some key localised benefits to energy users. And EDP is already heavily invested in distributed generation. We know that to fully capitalise on these kinds of investments, pairing solar energy with long duration energy storage is pivotal to achieving 100% reliable and available energy in a cost-effective way. And really what I'm proposing today is to partner with you to initially deploy multi-day energy storage solutions from Endua that can capitalise on this existing solar asset base. However, I'm also looking at this as a stepping stone towards a broader relationship that can begin to unlock the role of hydrogen in EDP's future decarb strategy beyond its applications in energy storage. So who are we? Endua is an Australian company that is engineering a suite of technologies that enable distributed on-site production of hydrogen. Our approach is uniquely focused on making it possible to produce hydrogen where it's needed, when it's needed, even at smaller scales. And this eliminates the need for long-distance transportation and storage and reducing the associated costs and impacts from that. Our first product that leverages this kind of approach is the Endua Power Bank. It's a self-contained, rapidly deployable energy storage system that meets the demand for commercial and industrial operations that require 10 or more hours of uninterrupted renewable electricity that's delivered on demand. Why does it stand out in the energy storage landscape? Firstly, by its use of hydrogen. So we're splitting water via our proprietary electrolyzer, storing the hydrogen gas in large quantities and converting it back into clean electricity on demand via fuel cells. Secondly, hydrogen storage can be expanded at a marginal cost. And this is the #1 criteria for multi-day energy storage systems. Eventually, we envisage that installations can expand to months of stored capacity, or even enable grid-scale systems that can act as virtual gas peaker plants locally. And thirdly, and probably most importantly, is we've standardized the entire hydrogen value chain into a modular product that's fully packaged and ready to go. This massively reduces the complexity and cost of deployment and reducing project timeframes from years down to months, making financial and regulatory approval much easier. So what are we proposing? I'm proposing a collaboration here to deploy and operate Endua power bank systems alongside an EDP distributed solar installation. The aim of this project is to quantify and demonstrate the role that long duration storage can play in maximising the capture and utilisation of spare energy generation capacity under real world conditions. Furthermore, the project is a low effort opportunity to accelerate our knowledge and understanding of renewable hydrogen and really get hands on with it. It's providing rapid access into a complex end-to-end hydrogen ecosystem all on a single site. It just covers the entire upstream and downstream production chain. So I expect that will generate further insight into the business models and technical challenges that we're going to face in the future around hydrogen. So why are we the team to partner with? We have deep expertise and experience across hydrogen technologies, manufacture, and growing global startup business. We're backed by the Australia's National Research Agency. We have Ampol Australia as a shareholder, which is the leading supplier of fuels in Australia and New Zealand. And we're also funded by some of the deep tech venture capital funds in Australia. We would be thrilled to join forces with EDP. I'm very excited to be implementing strategies that can make a change today and not in 10 years' time. And with that, I'm happy to take questions from you.
Thanks, Paul. So let's go for the Q&A. Who has questions?
Hello, Paul. Thank you for the presentation. I have a couple of questions.
Sure.
One is regarding the price. If you have an estimate of the pricing of the technology per kilowatt hour, sorry, put an example. And then the round trip efficiency as well, if you have some numbers on that, on the AC side, could be.
Yeah.
Thank you.
Yeah, of course. So price-wise, we're on par with large-scale lithium battery in dollars per kilowatt hour sense. Obviously, that cost needs to come down, and that's one of the key things we're working on here is how do we take the cost out and engineer cost out of these systems. So that's a future roadmap. The second question was around round trip efficiency. So the input to the power bank is AC power, and the output is three-phase AC power. And so you can't fight physics. And so the efficiency is lower than, say, other energy storage technologies. The theoretical maximum efficiency is 50% or less. Really, this is about the economics of the system. So what is the dollars per kilowatt hour of electricity that I'm consuming by the end consumer? And with the low cost of input energy and our work to drive down the CapEx costs of these types of systems, I believe we can get there on those economics as well.
Thank you, Paul.
Pedro, go ahead.
Hello, Paul. Thank you for your presentation. Two quick questions. So the first one is, you are connected directly to solar, so you don't have the support from the grid, if I understand correctly. Does it bring extra degradation to your stacks because you don't have a constant power being supplied to the electrolyzer, I believe? And the second is, what is, on your view, the main advantage comparing to batteries? Is it CapEx or because if we are losing a lot on efficiency, the CapEx would need to be probably half of the batteries, right? So what is your competitive advantage versus batteries?
Yeah, sure. So on the variable power, so this is a big question in the industry in general. All of our testing of our systems we do with variable power levels. Obviously, they need a lot of time before we really see what the effects of that are. And so, that's one of the things that, perhaps we can answer with a little bit of time, but certainly we're designing for that variable energy input. In terms of, key advantages here, I think that, as I said, storing hydrogen as gas is 1/10 the cost of, the current battery technology. So it's very, very cheap to expand and have, store large amounts of energy for long periods of time very cheaply. And there's a specific engineering problem around the front end CapEx on those systems. But I think that's important. And I think the other thing is really the focus here is on making localized hydrogen generation viable economically and physically. And there's lots of added benefits to having hydrogen capability on site. So I see future revenue streams where we can overproduce the hydrogen more than just for energy storage. We can use it for refueling locally, production of downstream chemicals, byproducts that use that hydrogen. So I think there's a lot of opportunity there to unlock additional value streams.
Thank you.
Hi, Paul. I can do a couple of questions also.
Sure.
Thank you for your presentation. About the equipment that you have, mainly the electrolyzer and fuel cells, I presume you are not producing them yourselves. Are you sourcing them from other partners?
Yeah, so we're using PEM technology. The electrolyzer is our own design that we're assembling and manufacturing in-house, and we assemble the final power banks ourselves. Electrolyzers are the biggest cost contributor to these types of systems right now, and so that's where we're putting our focus. So partnering with the CSIRO in Australia, we were working with a team of electrochemists that had been working in this area, and then we've really built our electrolyzer off that base, that technology base. So there's a lot of engineering that's gone into that as well. But our ambitions are to be an electrolyzer manufacturer.
What is the TRL or the maturity stage of your electrolyzer?
Yeah, TRL, high TRL. So depending on the definition, 7 to 9. I mean, the power bank's getting close. These are assembled working units. we're looking to deploy them in the field this year. And so, you know, we're getting to high TRL levels on the products and the electrolyzer itself.
Okay, thank you.
Hi, Paul. Good morning. Regarding the membrane, what is the estimated life of the membrane that you're using?
Yeah, we're again, this is one of those big questions, but our target is 10,000 hours because I believe that we can reduce the costs. We don't need 50,000 hour life, and there is a almost a 12-month maintenance requirement on the products themselves. So I think we can get some advantages in terms of cost by trading off that operating life.
But you're not developing the membrane. You're using a commercial one.
Well, we're buying off-the-shelf membranes. We're coating them ourselves.
Mm-hmm. Okay, thank you.
Okay, thank you, Paul. We ran out of time.
Fantastic. Appreciate your time. Thank you, everybody.
Some extra time. So thanks a lot for your presentation, and we'll get back to you with the results in the next few weeks.
All right. Thank you very much, everybody. Have a good day. A long day.
Okay, so next we have Rami and Raphael from Plus Energies. Hi,
Hello.
Raphael.
Hi.
Good morning.
Good morning.
Hi. Is Rami joining us as well?
Yes. I mean, at
Okay.
least for the Q&A.
Okay. Yeah, so we are here with EDP and we're ready to hear your pitch. I don't know which one of you is gonna do the presentation. So go ahead, you can share your screen and
Okay, I'm going to present. I'm the one.
You have 4 minutes for the pitch and then we go for the Q&A.
Do you see do I see the timer somewhere?
Yeah, it's here. Do you see?
Oh, yeah. I see it now.
Yeah.
Okay. So I start now. Okay.
Yeah. Go ahead.
Okay, thank you very much. My name is Rafael Garcia, and we are Plus Energies. We want to build energy storage solutions for small scale applications. The problem we have identified for this program is the necessity of capacity increase in the grid and the huge investment needed. It's expected that we will need to increase worldwide the investment from 300 billion, with B, to 600 billion in the next couple of years. There is a bunch of energy that cannot be connected to the grid today, and we see this, let's say, utility scale problem coming to the smaller scales like residential of communities due to especially to the popularity of solar roofs. And we see the risk that, especially in rural or remote areas, the electrification in mobility or heating will not arrive on time due to these constraints. And this is what we see as the problem. The solution we see or we want to offer is a decentralized network of smart batteries that will eliminate the need of investment. That means, as I said, at a community or residential scale, also small industries next to villages or residential areas. Why we Plus Energies and not the competition? There is literally hundreds of producers of batteries, especially in Asia, but I think none of them could provide engineering services and design and will be willing to deviate from the mass production business to provide customized solutions. We want to offer that, and we want to offer it in a modular way. Keeping a standard is very important to keep costs low. We are also at the same level of cost according to our first estimations. Why not be big batteries or utility scale solutions? Because the initial investment is much higher, the complexity is higher, and at the end of the day, the kilowatt hour cost is also very similar. Although, additionally, it requires very expensive maintenance. This is why the pilot project we proposed is a case in which you're facing these kind of challenges where you see there is going to be a capacity increase, a need of capacity increase, but always thinking at a smaller scale, a small or medium-sized scale, where we want to offer a solution that is easy to implement, easy to maintain, and low cost. And with this case, what we will do, we'll analyze the generation and demand information, and we will invest time in designing the solution, because we believe it's easier to make corrections in the design phase than in the implementation phase. And most importantly, we will create, I think, I would say, I would not say for the first time, but it's quite rare that someone implement an algorithm that is based on caring or taking care of the use of grid. So far, there are many algorithms to increase savings, to do peak shaving, whatever. But in grid utilization, there is very little at this scale. We will implement the solution. We are not installers. We will need to collaborate with installers, but we will monitor the performance. We can monitor remotely for sure. We have already these solutions, or we are working on that. And we believe we have a lot of synergies with smart grid companies. So it is desired for us to collaborate with a smart grid company, just as a hint. Yeah. At the end of the day, what we want to achieve, or the result should be that we can quantify how much can you save, but not investing in grid increase and by using this small battery solution. Because we believe that battery energy storage solutions are the most economical solution for the grid challenges, especially at a smaller scale. Thank you very much.
Right on time. Thank you, Rafael. Who has questions? Luis, go ahead.
Yeah, good morning, Rafael.
Good morning.
Are you using lithium iron phosphate batteries?
At the moment, yes.
Yeah. And for this system for 48 volts, are you using some 15 or 16 batteries, I presume? More or less,
16 cells for 51.2 volts. Yes.
Because the rated voltage at the front of the unit says 41.2, whereas the rated one is 48. What's the difference between those two voltages?
Sorry, I didn't get this. Where did this number come from?
Yeah, there is a picture in your presentation.
Yeah.
At the front, it says 51.2 instead of 48.
Yeah, 51.2 because it's 16. Yeah, the right one is 51.2. Yes.
Okay.
Yeah.
Yes, but just a comment. Is a 51.2 or 48? This is the nominal value, but usually the battery have the minimum maximum. So we have a different range. It's important that the inverter can cover the range of the battery. And what we have with our batteries is a modular battery, so we can scale the energy, so we can put it in series and parallel to get the required energy of the converter. Okay, so 48 or 51 we take advantage of using 51.2 because the BMS can having 16 instead of 15, so we take advantage of adding one energy more. Okay.
Okay, thank you. And who is the provider and manufacturer of the batteries?
The cells.
Yeah, the lithium iron phosphate.
The batteries. At the moment, we are working with Asian providers, and we are focusing two. Yeah, especially. Do you need to hear the name?
Well, we will be happy to know it.
Yeah. I mean, the main focus is in EVE. EVE we like, and they talk to us. So it's difficult that a big mass production cell manufacturer talk to us. So they open the doors to us, and we are happy with them. Yeah. EVE.
Okay, thank you.
Hello, good morning. Could you explain a little bit better how your business model would be?
I mean, the business model in general, or this specific pilot project case?
No, the business model in general, please.
I mean, we want to build batteries. We are developing our own batteries. We have our prototypes, and we will build batteries. At the moment, we are focusing in this battery rack that Luis mentioned at the beginning, 51 normal battery rack. And in our, let's say, product roadmap, I think it's a must to work on an all-in-one solution with inverter integrated, yeah. But we want to sell batteries. We want to produce and sell batteries, yeah.
Okay, but so you are going to install these batteries behind the meter, right?
Yes.
In order to solve grid constraints, as I understood.
Yes.
So how your economical model would be? So you are going to deploy the batteries, who's going to pay the batteries, who's going to pay for the flexibility from the client side?
Yeah, that's
the things that I would like to hear from you.
Yes, yes. At the moment, I think this specific case is interesting for the utility company, yeah, because they will save in grid investment. Normally, batteries are bought by the final user or the consumer, and they buy it. But could be that in some places they are not interested. And at the moment, in the markets we know better, which is Spain, is not that interested. But I think it could be interested, let's say, this is something we need to discuss with you because you know better, but some kind of renting or leasing batteries so that they can, you have an advantage and they have an advantage, but they pay for you, they pay to you. But this is to be defined. We need the pilot and we need to learn, and then we will define the commercialization, but there are different options, yeah.
Okay, thank you.
Hi, Rafael. Do you have any pallets at the moment, or any?
Yes, we have a pilot product. Yeah, I think I can even I think I have a picture here. Yeah, I can. This is the pilot we have in our. I mean, the prototype we have in our lab, and this is the software we are using. Yeah, or developing. Yeah.
Okay, perfect. Thank you.
Okay, we ran out of time, so thanks a lot. And we'll get back to you with the results in the next few weeks. Okay.
Thank you very much. Have a nice day.
Thank you. Bye bye.
Bye bye.
Thank you.
Bye bye.
Okay, so next we have Kim from AGEERA. John, you can let him.
Margarita, I just sent a request to the next startup. He was fine, but from 1 minute to the other, he appears to have disconnected. So just give us a few seconds, okay? Sorry. Yeah, so he just disconnected just now. Unlucky. So let's see.
Okay,
Let's see if he comes back.
Okay, let's just wait a minute. If not, then we can do the break, and then if he's available, we start after.
Yeah, let's just see if he returns. He was fine all this time. It was just now.
Yeah.
Some music while you wait.
Playing on my heart just like a Casio, breaking it apart so you can let it go. Wait another year, that's not original. I'm cynical, alright, let's go now. When all your dreams are gone,
João, I think it's better if we just go for a 10 minutes break. I mean, actually 15. Yeah.
Yeah, we have no sign of the startup. He probably lost connection, but he will be back eventually. But yeah.
Just before we go, sorry, do you have any idea when LAVO would be pitching, the one that got behind?
We are still confirming if they can make it in a schedule at the end of the day. Still confirming. They haven't replied yet. Yeah.
Okay, thank you.
Yeah. Okay, so let's be back in 10 minutes, yeah? Okay.
That's not original. Cynical, alright, let's go now. And all your dreams are gone, and you're still holding on. You waited for too long. I know, you know the song. And all your dreams are gone, and you're still holding on. You waited for too long. tears I've cried for you, the time that we have spent together, riding through this English weather. And as the pressure builds, so does the tension between you and me. Time has gone so fast, watching the leaves fall from our tree. And baby, I just want you to know I still love you, love you, love you, love you, love you,
And the grass is always greener on the other side. Maybe you should come take a trip sometime. Oh, you seem keener when they turn to night. Got you dripping out your mind, baby. Tell me it's a sign. As the pressure builds, so does the tension between you and me. Time has gone so fast, watching the leaves fall from our tree. Baby, I just want you to know I still love you, love you, love you, love you, love you.
Hello.
Hello.
Is everyone back? Okay.
Hello.
Okay. Okay, so we managed to Kim managed to come back into the meeting. So we're gonna have AGEERA, the startup that we were supposed to have before the break. So João, you can let him in.
He should be entering now and not teleporting away this time.
Yeah.
Hi,
Hi, Kim.
Hi.
Hi, welcome.
Thank you.
So we are here with EDP and we are ready to hear your pitch. So you can share your screen, and you have 4 minutes to pitch. So you're ready? Yeah, we can see it.
Let's start from the beginning. That will be the best. So my name is Kim. I'm a business development manager at AGEERA. AGEERA means, in Hebrew, means storage. So today we're going to speak about shortly about AGEERA and the solution we provide. So speaking on modern life, power demand is increasing and the availability and quality is falling. Okay, we're facing the challenge through many points: the population growth, the accelerating renewable energy transition, the cross-sector electrification, especially in transportation, and another challenge is growing volume and complexity in data management. Of course, climate change is a global challenge, and the increasing frequency of emergencies and natural disaster. So this is turning a passive consumption into active revenue generation. So before our solution using a storage system with our software, so passive consumption with no control over the rates, time of use. When you just plug and you consume electricity, and after AGEERA solution, so the consumer becomes an active in managing the supply of electrician. So what we do is we're creating a synergy in the best part of the value chain. We are buying batteries from manufacturer. We're going into the project with an integrator. It doesn't matter really who it is. And then the developer, we are the entrepreneurs in the project. We are the developers of the software and the solution. We're doing the EPC and of course the management of the whole life, the project life, and in the end, the consumer. So AGEERA was established in 2017 by a number of entrepreneurs that are highly professional in their fields. So we have Idan Libes, is the co-founder, is a researcher. We did a 4.5 years research about management of energy through storage. We have Avia, which is our CEO. Aviad is our VP, and Shachar is our CTO. Shachar was a senior, highly qualified in the telecom area. So what we are offering is a software, AI driven, with a lot of machine learning algorithms, but our solution goes into three critical things. We have an EMS controller. Our energy management system is on-site command and control running force field hardware with a cyber security. We have continuous monitoring on all on-site consumption generation assets from various vendors. We have our VPP platform, means virtual power plant. So a distribution of many storage systems can create a virtual power plant without building a power plant. And the third is a vehicle to grid module. We can actually
It's not my connection, right? Kim just
Yeah,
stopped.
yeah, I think
Yeah.
I think he did the same magic trick, unfortunately.
Okay. He was almost finishing the presentation, so
Yeah, he
how
was.
about how about if you have questions, you can write them here and we can forward them to Kim offline.
Yep.
Okay, so I'll just give you just a bit to write questions if you have.
Oh, we're very sorry. I'm gonna see if he connects again. No sign of him yet. Wait, he's back. So let me see if he's okay.
Okay.
Ok, ele deverá entrar agora.
Okay.
He should enter now.
Okay, Kim, you're back.
Sorry for that.
So you were almost finishing your presentation, right?
Yeah. I'm about to finish.
Okay.
So storage system for us is a very short development and a long-term investment. We do it by multiple business models. It's either we are the entrepreneurs, or either we do it as a SaaS or revenue sharing. So our product eventually is a real-time energy and financing management on a real time. And we already won a few of grants. We have a record of about $2 million grants. And we already have a signed contract of 112 megawatt hours, working hardly to make it bigger and bigger. And that's the numbers. That's the economy side of the growth. And as I spoke earlier, so a bunch of storage system at the end is a virtual power plant, and that's the strategic thing. We're showing some strong global growth of storage system, and that's about it.
Okay, great. So now let's go to Q&A. There was a question here from Julie for you. Is your solution market agnostic, or is it focused mainly on a specific market?
No, it works on a global market as same as a local market. Wherever, so storage system brings in three main applications: revenue, power quality for stabilizing the voltage, and a backup for emergency. So wherever there is an arbitrage, a differences between a tariff, local tariff, so there is a possibility, a financing possibility for deploying of storage systems.
Okay. Does anyone have another question? No? I think that's it, Kim. If we have other questions, you can also post on the chat and we'll forward them to Kim. So thanks for your presentation, and we'll let you know the results in the next few weeks, okay? Thank you.
Thank you, Margarita.
Thank you. Okay. Okay, next we have Alan from enSights AI.
Okay, enSights is coming in now.
Okay.
Hello, everyone.
Hi, Alan. Welcome.
Thank you very
Welcome
much.
to the Energy Chapter. We are here with EDP and we are ready to hear your pitch. So go ahead, you have 4 minutes.
Perfect. Thank you very much. So hello, everyone. I'm very honored and excited to be here today. My name is Alon Mashkovich, and I'm the co-founder and the CEO at enSights. We are developing the next generation of the operating system for distributed renewable energy assets with full automation and optimization in order to maximize the performance of your assets. You all probably know that we're in the beginning of a new revolution, energy transformation, electrification, moving from centralized polluting power plants to distributed renewable energy sources. This change brings lots of challenges. Our focus is on the software side, legacy versus advanced algorithms powered by AI for better utilization and control. Moving from SCADA to different legacy controllers to where we are focusing on cloud computing to orchestrate your distributed ecosystem. Our technology enhances operational efficiency of existing assets and simplifies the deployment of new ones. We are here to address the following challenges by EDP. Curtailment. Our prediction engine assists in optimizing your curtailment strategies and ensures maximization of your value during these events. And even when applicable, we also provide guidelines to avoid curtailments altogether. Around storage optimization, our platform has already built-in integration for different storage systems as an individual entity or part of a microgrid virtual power plants. It optimizes the operation of your storage systems by predicting our power consumption demands and results maximization of your revenues. In addition, we also generate optimal scheduling for the BESS, battery energy storage systems, while assuring the state of health. So this is how we do it. The journey starts with the basic data acquisition from all different renewable energy assets, moving to the next steps of management and automations. And the top layer is the AI for predictions and optimization. Think of enSights as your digital brain trust, connecting data, assets, and people for smarter operation and maximize the value. And this is how it looks like. Our cloud platform extracts actionable insights from your data, enabling minimized curtailment. Through predictive analytics at real-time performance monitoring, we identify potential events before they occur and allow you proactive adjustments into your energy production and distribution. The most important part, I think, is the value that we bring to our customers. And this is the proven result. Since we have been established in the end of 2021 till now, we have captured massive market share in our local Israeli market share, around 30%, managing over 6,000 distributed assets, over 1 gigawatt of installed capacity of systems. We are here to demonstrate to you our efficiency of our solution and propose the following outline of our pilot, focusing on reducing curtailment and optimizing the storage. In collaboration with your team, we will implement our platform in selected projects or region, showcasing our data-driven approach. By that, we aim to validate our solution, impact your operation, and highlight tangible benefits such as increased revenue and improved efficiency. So let's take the next steps towards maximizing the value of renewable energy. And I invite you to join and schedule the next meeting with our team in order to discuss how we can better use of our renewables in order to bring tomorrow now together. So thank you very much, and I will be more than happy to answer each and every question.
Thank you, Alan. Thank you for the presentation. Who has questions? Who wants to start?
Yeah, I have a question for you, Alan. Pleased to meet you. What's the AI platform that is running below your system? You use a proprietary AI platform or a commercial one?
Our proprietary algorithms. On our team, we have doctors from Tel Aviv University and different algorithmic engineers. So we have different layers. We have our own proprietary advanced algorithms. On top of it, we have different modules that we use of LLM. Today, we are using ChatGPT Turbo, and we engaging with more additional in order to learn from different use cases and enhance more benefits for actionable insights.
Okay, thank you.
Hi, Alan. Thank you for your presentation. What type of data would you need for the pilot from our side?
Connecting to your existing assets or to get the raw data, electric quality parameters from the asset level, revenue grade meters, the distributed assets, inverter level, again, each and every input. On top of it, we have different layers. So we have our own proprietary satellite data and weather adjustment data that we're using from different sources in order to maximize the benefits and the value around it. But the basic from your side is, if you have also the plannings of the asset, it also contributes in order to establish a digital twin in the better way and start to provide you versus expected, projected versus expected. Actual versus expected, sorry.
So you can receive inputs from our SCADA, right?
Sure.
Okay, yeah. Thank you.
I also have a question. So if I understood correctly, so you are going to optimize the assets, namely the battery, to minimize curtailment, but are you also going to optimize the battery to capture other revenue streams like arbitrage or participating in ancillary markets and so on?
Definitely. Again, depending on your and mutual target function, because the use cases can be different about ancillary services specifically. There are many types of use cases. So today, most of our focus is in order to make arbitrage from one side, from the other side, energy resilience for asset independent, for energy independency for different use cases, ancillary services such as frequency regulations. And again, there is a very, very wide range depending on the use case.
Well, Alan, thank you for the presentation. I have two questions. One about the storage. Do you get the data from the BMS itself, or which level of data do you get? And the other one about the business model, if it's like an annual fee, or how does the business model look like of your solution?
Perfect. So about the battery systems, depending on the battery that you use. So for example, when you use Tesla batteries, usually they have their own site controller that we connect into their battery. In other use cases, there are sometimes that we install, or the customer installs a computer on site that we connect to him and we install our software on top of it. But again, usually we connect to the battery systems and add the additional computing on site. About I hope it answered the first part.
Yeah.
About the business model, so it's SaaS, software as a service, and price to scale. So it have different layers. When we talk about ancillary services, there are different revenue streams that we also participate in the revenue sharing.
Okay. Perfect. Thank you.
Just a last question from my side. So would your pilot will work everywhere, or are you targeting specific energy markets?
Good question. It's about the go-to-market strategy. So today we have already connected assets globally. We have in Spain, we have in Africa. Our go-to-market strategy is to focus on direct sales in the US. In the current round, I will be relocating to the States, but we already have approved pilot in Japan and in other regions. So the product is already ready to scale. And the adjustments usually is from the financial side in order to adjust to the market regulations around the financials. The kilowatts and the electric engineering, usually it's the same.
Thank you.
Okay, thank you, Alan. Thanks for your presentation. We'll let you know the results in the next few weeks. Okay,
Perfect.
have a great day.
Thank you. Thank you very much. Bye-bye.
Bye. Okay, next we have Landatu Solar, and we have Christian who's gonna do the pitch. So, João, you can let him in. Hi, Christian.
Hello.
Oh.
Hello, everyone. Can you hear me?
Yeah, we can.
Yeah, we can.
Okay. I'm going to share my screen.
Okay. So we are here with the ADP, and we're ready to hear your pitch. You have 4 minutes to pitch, and then we go for the Q&A. So feel free to start.
Okay.
Yeah, we can see it.
Okay, so my name is Christian. I'm the founder of Landatu Solar. In the last few decades, we have seen how the solar energy increase, but we are still far away from the decarbonization goals. So the point here is how we can get or reach that goals. In Landatu Solar, we design products that to simplify solar installation. And what why and how we do it. Nowadays in the flat rooftop, the installation are made using concrete ballasted support. But the trouble with this kind of support is that are very heavy, difficult to install, difficult to transport, and you need crane and so on. Our solution, this one, a water ballasted support, is just a support in two pieces that are stockable, and you can fill with water or other materials like rubber, sand, or whatever. So it's easy to install and easy to transport. This is some of our competitors. Our main advantages is that thank you to our transportation advantages, our market is international or global. A product that has been in market for less than 1 year, and we have had a lot of success in a small project and in big one as well. Other problem with the solar energy is that requires a lot of space. The solution is floating solar energy, a project that are made using floats, and in which you can put the solar panels, and you can put in irrigation pond, dam, and so on. As you know, floating solar energy has a lot of advantages, but the main disadvantages is that the cost of the transportation of these floats are higher or greater than the cost of the float itself. Our solution is Lamaru, a float system that as well is stockable, so we can transport 6 times more than our competitors, and very easy to install. But the main difficulty of this kind of installation is not the float itself, is the designing and of the mooring and anchoring system. So in Landatu Solar, we have our own mooring system, and we develop a specific software to design a floating solar system. At the end, if you want, I can show you a demo of this software. This is very unique software. This is some of competitors. Our main advantage is that we don't transport aid. Our business model is to sell the product for the rooftop and also for the floating system, and the design and construction of the floating solar system. Landatu started few years ago. We made a first MVP. The past year we launched the product and we made the first floating solar installation in the north of Spain, in Basque Country. So the goal for the next year is to make bigger and bigger projects. And this is our team, with Juan Pedro is an aeronautical designer, and Alfredo is also a co-founder, and Natalia Gracia Unai. And Landatu Solar was born with the intention to become a leading company in solar energy, providing products and solutions to accelerate the energy transition. Thank you to all.
Thank you, Christian, and thank you for respecting the time. It is very, thank you. So now let's go for Q&A. Who has questions for Christian?
Yeah, I have a question for you, Christian. Good morning. What's the volume of every floater?
We have different floating. This one over here is about 56 liters, but we have another to 90 liters of volume.
90.
90, yeah.
90, no 19. 90. 90, okay.
90.
Okay, Andres, go ahead.
Hi, hello. Thank you for your presentation. I was wondering if you're considering installing in offshore conditions at some point.
Yeah, this is our big goal in the future. We expect to make a MVP in the offshore places the next year with a company named Technalia. But now we are developing a small projects. But in the future, we expect to reach that point, that goal.
Okay. And secondly, on the question on the software that you developed for mooring systems, is that based on another software, or is it wholly proprietary from your company based on a potential?
No, we develop ourselves. If you want, I can show you a demo, but I don't know if it's possible for you, but
yeah. No. I was just wondering, but thank you for your explanation.
Okay, Jorge.
So the software allow you to put the anchoring system and calculate automatically all the forces and all the forces in all the anchor and mooring system. So it's very easy to use, and it's a big advantage of our company. I think that nobody in the industry have a software like this.
Great. Thank you, Christian.
Hello, Christian. Just one quick question on maintenance. Could you elaborate a little bit on type of maintenance required for this type of devices?
In the floating system?
Yeah. Is there anything that to take into consideration for maintenance?
No, we put some flows in order to make the maintenance. I think in one, maybe you can see here. So in a row, between the row and the next row, you put some flows, and you can make or use other. There are many companies that they usually make this kind of maintenance, but we don't have a specific one.
Okay.
Yeah, maybe just a quick question on my side. Can you comment a bit about marine growth? Any sort of protection, coating, or any experience actually related with marine growth, and how could this affect
I can't hear you, sorry.
Oh.
Christian, the question was regarding marine growth in the floating PV system. Do you have any protections or anything?
Yeah, I don't know if you can hear me better now.
Can you repeat the question? Sorry.
Yeah, my question is if you can comment on marine growth, like any sort of coating or protection, or on the other hand, experience on how the marine growth can affect the structure of the platform, so increased weight and
if there's any sort of coating that you can have to avoid this.
The product for the offshore condition, it will be very, very different. It will be like floats. I don't know how to explain, but they don't going to be like this one. And about the protection, we will see. We don't have any experience yet in this area.
Thank you.
Okay, that's it. Thanks a lot, Christian, for the presentation, and we'll let you know the results in the next 2 weeks. Okay.
Okay, thank you. Bye.
Thank you. Have a good day.
Bye.
Okay. Next we have HELIUP with we have Yannick who's gonna present HELIUP. So João, you can let me know.
Hello.
Hi, Yannick. Hi, welcome.
Can I share my screen?
Wait. Yeah. Sorry, I have a bit of delay. So welcome. We are here with DDP, and we are ready to hear your pitch. You can go ahead and share, and you have 4 minutes to pitch.
Thank you. Good morning, everyone. I'm Yannick Vescetti, CEO, co-founder of HELIUP company. Sorry, just check something. As you might know, there are lots of surfaces of available rooftop everywhere in the world. In Europe, the amount is so big that it could almost produce all our target in terms of photovoltaics. But there's one big issue. This is that most of those big buildings made of metallic frames cannot be covered with solar panels due to low bearing capacity. So depending on location and type of buildings, this value is between 40 to 80%, which is significant and represents a real issue now. HELIUP is a startup created in September 2022. We want to develop and bring lightweight solar solutions for this existing building rooftop in order to produce green energy at a local level, reduce the environmental impact, of course, because using rooftop is much better, and also bring industrial sovereignty within Europe by making our own panels ourselves. Our innovation is made on 2 different items. The first one is a lightweight solar panels, which is 60% lighter than a conventional one, without losing any performance or reliability, durability, quality. So this is a patenting technology from CEA, a big research organization that we benefit from a license at the moment, and where I was working previously. The other improvement is also how to integrate this panel into the building in order to make sure that it doesn't bring any harm, any damage to the building with the time. So the integration is smart, and also to make the PV system more sustainable using less material and easy to install. So what is the value proposition? Depends on the final customers. There are 2 types of main customers in our case. There are the building owners who can own big parks of buildings sometimes. So by putting solar on their building, they will improve the building energy efficiency. And they also will, with time, have some saving on electricity cost, and also some stability over more than 20 years. It's also bringing value proposition for PV developers, since it brings a direct access to surfaces for PV development. And this is also another issue at European level, since we need to keep lands for other applications as well. And it's much easier to install solar into a rooftop, so the permitting time is reduced. So regarding those solutions, HELIUP brings a cost-effective solution. So our panels can be very low cost in mass production, so we can have very competitive levelized cost of electricity in the end. The product has a high quality and performance, which means that the performance will remain high during all those more than 25 years. And also the integration, it's well studied in order to match very well with the building certification specification on insurance. At the moment, we have a pilot line where we are in our main site in Bourget-du-Lac near Chambéry. A pilot line building making between 100 and 200 kilowatt peak per panels per month. And we also invested into a production line of 100 megawatt peak per year, so 500,000 square meter of panels every year, which will be installed in June and operational next September. In order to, considering the pilot topic, so with EDP, we'll be very happy to do one or several pilots on different building configuration out of France. Maybe think about doing a very large-scale pilot on logistic building. This hasn't been done yet, so there will be opportunities to match logistic building with solar solutions. And of course, try to do it in a smart way, so set up some monitoring system and inspections in order to have a good control of the production over time. I remain available for any further questions.
Yeah, thanks for respecting the time. Go ahead, Luis.
Okay, good morning, Yannick. From the pictures you share, it's not clear to me whether your system is monocrystalline or polycrystalline. And I assuming it's monocrystalline.
Yes, any silicon solar cells nowadays are monocrystalline, and we use the last generation, the highest efficiency we can find, and we integrate and certify the panel with those cells.
Thank you. Like the ones behind you.
Exactly.
Thank you.
Hi, Yannick. Thank you for your presentation. How does the installation process of your solution differs from the conventional one?
Yeah, good question. I haven't been in details about this. So basically, when we make our panels, we deposit. This is an additional step which does not exist on solar panels. We deposit on the back a double-side tape. So once you're to set up the panel, it's directly glued onto the waterproofing membrane. So you just have to peel off the liner of the tape and to press it, and it's installed directly. So it takes less than 2 minutes to install the panel onto the roof.
Okay.
And it's certified regarding the building French standards. So we prove that the adhesion can last more than 20 years by running some aging tests. And this has to be done on any types of new membrane.
Okay. And are there any maintenance costs associated with your solution that we don't have with the conventional ones?
No, we believe it's actually even simpler in our case because the soiling, for example, is much easier to deal with, and the access to the panel on the rooftop could be a lot easier as well.
Mm-hmm.
But since it's almost the same electric system, so it's the same type of inverters, the same voltage and current outputs, it's very similar regarding the electrical system to a standard PV system.
Okay, thank you.
You're welcome.
Someone else has questions?
Maybe I have one, Margarida. If nobody is in the queue, I'm not seeing. No. Yannick, one question. Just for us to have, let's call it an expectation, does your panel have compared to the normal panels, does your panel have an overcost? So efficiency, you said that is the same, but in terms of prices, what can we expect from using your panel instead of a normal panel? Just for us, a ballpark.
Yeah, once this 100 megawatt line is running full capacity, the panel will be slightly more expensive than the panel made in China. But if we look at the system cost, since the panels are installed more quickly and there's a lot less material to set up the panels onto the roof, we are very much convinced that the system cost could be equivalent or even less than the conventional systems. So hence we could address existing building rooftop which have low bearing capacities with a very competitive solution heading to level of cost of electricity very, very low.
Yeah.
Depending on the location, of course, and how much sun you have every year, but it's 80 euros per megawatt target minimum, maximum we're targeting with this solution.
Okay, thank you. And second question, in your presentation, like in the last slide, you talked about the software, some kind of software. I didn't catch it.
Probably not. Maybe I went too fast.
Okay.
No, we don't have any software. So
okay. To clarify. Okay, thank you.
You're welcome.
Okay, so that's it. Thanks a lot, Yannick, for the presentation. And yeah, we'll let you know the results in the next few weeks. Okay.
Thank you. Have a nice day, everyone. Bye.
Thank you. You too.
Bye.
Okay. Next, we have Matthias from Replace, which is renewable energy place. So you can let him intro. Hi, Matthias.
Hello, nice to meet
Hi,
you all.
welcome.
Thank you.
Yeah, we are here with DDP and we're ready to hear your pitch. So we see your screen. And yeah, go ahead. You have 4 minutes to pitch and then we go for Q&A.
Perfect. To combat climate change and provide affordable energy, 135 countries committed to net zero. Lots of projects need to be built, as today, only 35% of the energy sources are renewable. Between you and me, it's a fantasy, because 80% of renewable energy projects fail during development because of inaccurate and inefficient site selection. I'm Matías Sigal, CEO of Replace. For the last 4 years, I was developing renewable energy projects, and I saw firsthand how inefficient the process is. In fact, one of my projects failed after 18 months of work. The main reason why projects fail is, first of all, how developers develop these projects. They use geographical information systems, GIS, or maybe they use Google Maps to manually find the locations. Another way is to hire brokers or consultants, or maybe DP just send people with the car to an area near a grid connection and try to find a land in that area. So, because of this manual process, 80% of the projects fail, either because of there is no grid connection point, the landscape have a problem, you cannot get the permits for the regulations, or you cannot close the land. So Replace developed a technology that is a proprietary data analysis algorithm, which helps to maximize the return of investment of the project and reduce this 80% development risk. This is how it works. The user enters the technology, the size, and the region of the project. For example, this is Canada. Then the technology analyzes several data sources, in fact, 40 proprietary data sources. And in one click, we get to the best parcel of land, and we understand why this is the best location for the project. We analyze, as I was saying, 40 parameters in all parcels in an area. In Canada, there are 2 million parcels. If we invest 30 minutes to do it with your current methods, it will take you 120 years. That's why you don't do it this way. But the technology can do that. I'm not doing this alone. We have more than 100 years experience in renewable energy, data, GIS, and software. We have great investors from our first round, and we are working with companies like EDF Renewables, Doral Energy, and many others. So here, I want to open to EDP the opportunity to become the most advanced project developer in the industry with the goal of accelerating the energy transition. We want to help you develop projects more efficiently. And I suggest a pilot where first EDP will tell us which is the scope of the pilot. For example, Spain, the US, Portugal, Brazil, or another region, and then a technology, utility scale solar, agrivoltaics, and it can be also community solar, or other you have in your mind. We are very scalable, and some of our pilots are with these examples, in fact. Then we will do the homework and adapt the technology to this scope and deliver the technology for EDP to find locations for around 3 months. I want to open the opportunity to develop technology that will help accelerate the energy transition. Thank you.
Thank you so much, Matthias. Right on time. So now let's go for Q&A. Luis, go ahead. Yeah.
Yeah, Matthias, congratulations for your presentation. How many
you, Luis.
parameters or factors are you considering when making this ranking? That's the first question. And the second one is, how can the user modify the weighting of these different parameters to get to a final ranking?
Yeah, I love your question because it means you understood perfectly our technology. We are currently using 40 parameters. The parameters come from the 4 problems we identify. So from the grid, from the landowners, from the regulation, and from the landscape. Regarding landowners, we can also in some markets connect to the landowner, so make the development go to the second step. And regarding the weighting, so our renewables expert define a preliminary format for the market. So that's why we take around 1 month to adapt to a new market. However, we are then sharing this to the user, and the user will modify it to your own development, let's say, risk adversity, let's call it. We want to do it like once the technology is commercial, the user will do it in their computer. But it's totally flexible in terms of how we weigh the parameters. Maybe you care more about the size of the land, and another company care more about the distance to the grid. So, but you understood it perfectly. We are weighting the parameters to get to a final result.
Okay, thank you.
Hi, Matthias. Thank you for your presentation. Are you focused in a specific market, or are you able to work in any geography? Because you mentioned that you need 1 month to adapt to one market, right?
Yeah. So we are very, like, we want to provide quality. It's not a GIS that is for all the world, and you just use it. It's a technology, a data analysis technology that we want to provide value. That's why we do it per market. At the moment, we have few pilots with big companies, as I was saying, and few others about to be signed, hopefully this or next week. And these markets are Canada, US, Israel, and Spain. So I know EDP is big in US and Spain, apart from others. So we are also open to do it in others with you. But if you want Spain or US, we have a lot of homework done. In Portugal also, because as you know, we have the same interconnected system. And at the beginning, when we started, we got letters of intent from some companies from Portugal, because they are, the problem is big as well to find locations, and it's booming because of how complicated it is in Spain now to get grid connection. So bottom line, we have it ready in some markets, but for the pilot, because it's CDP, we are open to discuss another markets as well.
Okay, perfect. Thank you.
Hi, Matthias. Thank you for your presentation. Is your solution specific to PV plants, or would it be also be potentially used for wind farms?
Yeah, so it's a great point. Now, the pilots we have are for utility scale solar, agrivoltaics, like putting solar on top of agriculture, and we are building one for community solar. And then the goal is to deploy those like technologies commercially. We are very scalable to wind, and in fact, our renewables expert is an expert on wind. He built 12 projects himself, like in his previous job. So we are like, now what I show in the demo was for solar, but it's in our pipeline to include wind, to include hydrogen and storage.
Okay, thank you.
Okay, so that's it. Thanks a lot, Matthias, for your
Amazing.
presentation. And
Muito
we'll let you know
obrigado.
the results in the next few weeks. Okay.
Perfect.
Okay,
Bye
bye-bye.
Thank
bye.
you. Bye. Okay, we have the last startup before the next break. We're gonna have Angela presenting Imageryst. Then you can let her in. Hi. Hi, Angela. Hi. Welcome. We are here with DDP and we are ready to hear your pitch. So you have 4 minutes and go ahead.
Perfect. Do you see my screen?
Yes, yes.
Perfect. Okay. Hi, everyone. My name is Angela del Carmen. I'm the CEO and co-founder of Imageryst, the platform that has the goal to democratize the access to geolocated data to any kind of user at DDP. Energy company needs data to make decisions, and this data needs to be reliable, global, and repeated in time. And we think that the satellite imagery is the perfect solution for it. But what is happening? They are really difficult to process. You need to have a qualified and expensive team, and you need to know how to manage big data sets. That's why we have created Imageryst, the platform that automatically extracts geolocated data from satellite imagery for any kind of users. How does it work? Our platform has an easy-to-use interface where the user just selects the asset that they want to analyze, let's say a solar farm, a parcel, an aero, and then the attribute that they want to extract for it. Let's say the slope, aspect, radiation, the limit of the parcel. Then they decide when and where to launch the analysis, and they get all the data through an API. In this way, we have a no-code platform for non-technical users where people can extract any kind of data without any knowledge about satellite imagery. Just to simplify the technology, we have as an input different imagery providers. Solar, drone, satellite imagery, LiDAR, or if EDP has their own images, they can upload it to the system. Then we apply pre-processing and pre-processing algorithms and also deep learning to be able to identify objects in the images. And then the user just get the data through the API or through the platform directly. This technology can be used for multiple use cases and it's really transversal, but I'm gonna focus on the use case that we have covered for the pilots that we are proposing for EDP and also for the one that we already have with our clients. Okay. The first one is optimize the construction. With satellite imagery, you can identify the ideal spot for solar farms, aeolic plant, and green hydrogen pipelines, and also monitoring the progress and the status of the maintenance. Another use case that we are working with Iberdrola right now is monitoring the status of the distribution grids by knowing the type of vegetation and the health of the vegetation close to the power lines to avoid fire risk. Another use case that can be really useful for EDP Solar could be the identification of the potential rooftops, understanding the energy potential and understanding how height it is, the slope, the aspect, the radiation of the rooftops. And last but not least, we are developing an environmental impact platform to identify how we are applying this kind of elements when we develop a construction. Okay. So we are a small but dedicated team. We are 6 people with more than 20 years of experience in the geospatial industry. We're already working with energy companies like Iberdrola or Neoenergia. We have different backups like Ship2B Ventures. We've been one of the finalists of the South Summit competitions. And we would like to be part of EDP Startup Bootcamp because we have a deep knowledge of the technology, but we really need to understand how useful it is for your company. We have a scalable solution with international focus, but again, we need your knowledge to develop these solutions. We would like to co-create a solution with EDP. So thank you so much for your time and hope to see you all in Singapore in April. But if you have any questions, I will be more than happy to answer them.
Thank you, Angela. Perfect timing. Let's go to the questions. Who here? Yeah, go on, Falda.
Hi, Angela. Thank you for your presentation. You mentioned that one of the use cases that you can work with EDP could be the construction of solar PV plants, right? And you mentioned that you can identify ideal solar spots. So what is this identification based on? Only in land availability, or do you have other parameters?
It really depends on your use case. For example, we can identify if there is a empty land, and also you can identify if we already have solar panels in there. Okay, that's a use case. And in addition, we can identify how, like the slope, the aspect, if you already have vegetation in there. I mean, those parameters to be able to know if we can develop a construction there. Okay, but yeah, you can actually, one of the use cases that we have developed for one of our clients is identify the empty spot and monitoring the works of other competitors.
Okay, thank you.
Anja, good morning.
Good morning.
In your presentation, you position yourself in the value chain in the specific niche of data collection, not as image provider, not as analysis or visualization. Why have you focused on that specific segment of the value chain?
Okay, so my co-founder and myself come from the GIS industry. Okay, so companies like Carto, GeoLink, I mean, these kind of startups in Spain mostly. And we have seen a lot of time that our clients have the tools to visualize the data, to analyze the data, but they don't have the raw data to make the decisions. And they have like internal data, they have, knowledge about where, I mean, the client have any consumption, this kind of internal data, transactions and so on, but they don't understand the environment. And we have seen the solution in the market that are really, really technical. I mean, even though they are selling themselves like, no, it's for non-technical users, but then you need to know what is the satellite, and the frequency that they are passing, the resolution of the images. You need to know to understand all those parameters, and non-technical people doesn't know about them. Okay, so our goal is to democratize the access of this geolocated data to enable decision makers to be able to understand it.
Okay, thank you.
We have seen a gap in the market, basically.
Someone else?
I can go if nobody else is in the queue. Hi, Hanra. Thank you for your pitch. Two questions. First question, what type of satellite image do you use? So high resolution, low resolution? Can you live with just low resolution, or do you use some high resolution Sentinel images in sometimes? And regarding this use case of satellites, because we have already some PAX experience, mainly in the distribution grid using satellite to discover vegetation and lines.
I work for one of that company.
Yeah, so one of our big problems was false positives. So sometimes because of using low resolution, because of costs, sometimes you get a lot of false positives. How do you tackle this? Do you have some research done on this? Because sometimes you say that we have something in that spot of the network, we go there and then there is nothing there. So it's bad for everyone.
Yeah.
Can you elaborate on that?
Sure. Regarding the type of images, right now we are using free images like Copernicus 1, Sentinel-1, Sentinel-2, but depends on the use cases. We are combining different images like drone images, satellite imagery, and also LiDAR to be able to combine them and get the best resolution. We are talking to different providers and using the high resolution ones. It depends on the use case again. Okay. In this case, we understand that the client understand their needs. So, okay, for me, it is really important to have like 20 centimeters because, I mean, I need to have this resolution because it's in an urban area. But for example, in other areas, it's more than enough, like the free satellite imagery, because 10 meters is okay. Okay, it's really dependent on the use case. but we are open to work with different providers. Actually, we are working with different providers. And regarding the false positive, that's something that years ago, the quality of the satellite imagery was really inaccessible. Right now, they are launching satellite every single day, and we are getting more resolution and more revisit, the frequency that they are passing through. So we need to co-create with you this kind of solution to understand if there is good enough, basically. I don't have any answer for the number of false positives that we have, for example, for Iberdrola.
Yeah, just to know if you have some studies or some results already from Iberdrola
No,
or other companies. Okay.
No, in this case, for example, they create an alert system to be able to go to those areas that are really, they have high risk in this case. They say that it was okay. I mean, they didn't say anything about like, oh, we called in one of the cases. They don't say anything about that.
Margarita, can I just take one? I
Very
think
quick.
Very
Very
quick.
quick.
It's the business model. Just to clarify about the business model, if we go ahead with Imageryst.
Okay, so the business model, I mean, with the big corporates, we are starting with a POC for sure, because it's a way that, we start working with you guys. But then it's an annual license, depends on the square kilometers, the number of the algorithms that you're gonna be running, and also limited through the API calls. In this case, the platform is, for us, is more a way to sell the platform, I mean, to share the data, but most of the company, they ask for the API so they can add it to the GIS system that you already have established. Okay. I have a slide about the business model in case you wanna.
I think we don't have time, but yeah,
Okay.
thank you.
Sorry. Yeah, we ran out of time. So thank you, Angela. And yeah, we'll let you know the results in the next few weeks. Okay.
Okay. Thank you so much. If you have any question, you can contact me at angela@imageryst.com in case you have any question in the meantime. Okay. Thank you so much. Bye.
Thank you. Bye-bye.
Bye. Okay, so now let's go to a small break. Let's be back here in 10 minutes, okay?
don't have to be that cool. Just when I met you, a couple cuts later, now you're acting like a damn fool, and like a damn fool. So ungrateful, I sit you at my table, now you're hugging all the damn fool. So good, the blame is on you. There's no need to act like you still going to school and breaking all the rules. I'll take you back to class when I say you had your back in the beginning. Oh, that's right. When did you get so cool? I was here before you, don't forget it. Please, come on. Tell me, when did you get so cool? You don't have to be that cool. Just when I met you, a couple cuts later, now you're acting like a damn fool, and like a damn fool. So ungrateful, I sit you at my table, now you're hugging all the damn fool. It's so good, the blame is on you. There's no need to act like you still going to school, breaking all the rules. I'll take you back to class when I say jump off my dick for a minute. Yeah, you can't copy and paste that shit. Baby, when did you get so cool? I don't know. Yeah, I was here before you, don't forget it. I was here before you, babe. When did you get so cool? So cool. When did you get so cool? 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 Yeah, you know.
Hello. Okay. We have the next startup ready. It's Untitled Energy Labs, and we're gonna have 3 people: Yongsheng, Carl, and Wang Yan. So, João, you can let them in.
Hello.
Hello. Welcome. Okay, we have here Yongsheng. We are missing Carl. And, okay, there. Okay.
Carl hasn't entered yet, but he is not the one presenting, so
Okay. Okay.
he will enter in
Yeah,
the meantime.
okay. So welcome. We are here with EDP and we are ready to hear your pitch. So you can share your screen and start. You have 4 minutes to pitch. So go ahead.
Sharing my screen.
Yeah.
Can you see?
Yeah, I see it.
Okay. Good afternoon, esteemed EDP panels and fellow innovators. My name is Yongsheng, COO and co-founder of QE Labs. Today, I'm here to share how our autonomous drone electroluminescence is revolutionizing the solar asset quality management. At QE Labs, our mission is to ensure sustainable growth of the solar industry. We offer digital solutions to navigate solar investment risk, increase field inspection productivity through autonomous UAV, and provide AI-driven insights into PV system health. Solar PV is undergoing unprecedented growth. This growth, however, brings challenges, particularly in ensuring modules integrity in the ever-increasing asset size. PV module defects and over-degradation is a common issue. Recent studies by NREL shows that the median annual degradation rate is 0.75%, with over 60% of systems in USA experiencing over-degradation. CEA survey showed an alarming increase in PV module defects. It is important to identify and replace the defective modules to ensure optimal system performance. Traditional field testing of these systems is quite slow and often inaccurate. We recognize this gap and aim to create a more effective solution. To address this, we developed an autonomous drone EL mapping solution. It is a blend of unique hardware, software automation, and AI-driven analytics together with a digital twin platform. We are the only company in the world offering commercially viable drone EL mapping technology, providing lab quality results with ultra-fast speed. Our technology has been deployed in critical PV life cycle stages, from initial inspections to revamping and repowering, with over 1 million modules measured. Our notable projects include the 60 megawatt floating PV in Singapore and 200 megawatt PV farm in Australia, showcasing our capability for large-scale applications. For the pilot project with EDP, we aim to enhance system performance by identifying defective PV modules, which is the bottleneck in PV strings. Replacing these problematic modules is the lowest cost action and fastest way to enhance overall system performance. Our drone technology excels in identifying these defective modules, just like finding a needle in a haystack. The potential benefit to EDP by integrating our solution is significant. Assuming EDP solar asset aligns with NREL's finding, Improving performance by, say, 1% in 60% of underperforming systems could lead to an additional 5 million annually. Over 20 years lifespan, this translates to extra 100 millions in revenue. Beyond financial gains, this integration promotes sustainability, extend the asset lifespan, and maximize the potential of solar assets. It aligns with the ESG goals by maximizing clean energy production and efficiency, reinforcing EDP's commitment to sustainable development. Why support us? HELIUP is a spin-off company from Ceres. It's founded by multinational team of dedicated PV professionals. Our innovations stem from intensive high-impact research aimed to contribute to solar industry advancement. Thank you for your attention. We look forward to the opportunity to collaborate more closely with EDP.
Thank you, Yongchen. And thanks for respecting the timing. Thanks. So now let's go for Q&A. Who here has questions?
So, hello, and thank you for your pitch. I have some questions. So the first one is, are you able to perform electroluminescence tests during the daylight or only during the nighttime?
So electroluminescence works by injecting a current into the strings, and then we use a special camera to measure this special signal. So there is a technologies to do the measurement in the daytime, but in order to do the daytime, we need to do current modulations because the signal that we are detecting is very big. So if we do it in the daytime, we will sacrifice the inspection speed and the image quality. That's one thing. The second thing is, if you do it in the daytime, will disrupt the energy generation. So it is not recommended to do it in the daytime. So typically we do it in the nighttime where the system is no longer producing energy so that we don't have to disrupt the energy generation.
Yes, the results are less accurate, right? In daytime.
It's slower, much slower.
Yeah, okay. Also, my next question. So after you collect the images from the drone, you don't need the help of an operator to detect the cracks and the micro cracks, right? You have a software that can do that. Is that correct?
Yes, we have since measured 1 million modules, and with these millions of field EL modules, we are able to train our AI to detect all the different kind of defects. So
okay.
I'm glad to say that we are the only one in the world now that contain huge amount of field EL data that we are constantly training our AI to improve, detect all the different kind of defects.
Okay, thank you. And what is the autonomy of your drone, the one that collects the images?
Pardon? Can you repeat?
The autonomy of the batteries of your drone.
During the inspection, the drone will do scanning autonomously.
Yes.
And the battery time is about half an hour. But
Half an
this
hour.
is not really half an hour. But this is not a concern because usually typical inspection, we will have 4 sets of battery and 2 sets of charger. So that means the drone will be constantly inspection, and every 30 minutes you'll fly back, change battery, and then continue to do measurement.
Okay. Okay. Thank you.
Thank you.
Hi, Young. This is Lisandro from EDPR. So, what is going to be the main objective of the pilot that you would like to do with us?
So the main objective of the pilot we would like to do with you is we want to quantify what is the gain that we will be able to offer to EDP, and also for EDP to really see the importance of this technology. Right. Okay. So now we know that strings, typically when there's one module that's defective, we replace it. It will increase the whole performance of the strings, and we would like to demonstrate it with the EDP to really see this improvement.
Okay, so but the scope of this pilot based on this objective cannot be only limited to one PV site, right?
Yes, it can be any PV site with low performance or with the goal where you want to see how to further optimize your PV plants.
But the scope will be one PV site or more than one PV site?
With one PV site, we would be able to demonstrate this, but if you have more PV sites that you want us to demonstrate, we are more than happy to do that, because as you can see, right, our solutions, there are many case studies that is possible. So depending on the different sites needs, we can work on the different case studies. But the case studies that, of course, we are more interested is the revamping and repowering, where you have this system in mind where you want to further improve your system performance.
Like, which is the minimum size of the PV site that you will be interested in doing this, or at least to get some, I don't know, conclusive results.
So our throughput is about 5 to 10 megawatts per night, and we are thinking about 10 megawatts of the system size would be a good size for this pilot.
Okay, perfect. Thanks, Joel.
Okay, so we ran out of time. Thank you so much, Jan, for your presentation and for answering the questions. We'll let you know the results in the next few weeks, okay?
Okay. Thank you
Thank
for
you.
the opportunity. Bye.
Mm-hmm. Mm-hmm. Okay. Next, we have Horus Smart Detections with Lucas.
Hello.
Hi, Lucas. Welcome.
Thank you.
We are here with EDP and we're ready to hear your pitch. So you can go ahead and share your screen.
All right.
And you have 4 minutes. Yeah, we can see.
Okay. Hello, everyone. I hope you're all doing well. My name is Lucas Bastos, and I am one of the 3 founders of Horus. Here, we work to assist companies like EGP in achieving the best results regarding their solar assets. Solar power plants are composed of thousands of panels, making inspection and maintenance a major challenge for companies. Solar power plants like EGP's Pereira Barreto here in the state of São Paulo has more than 600,000 solar panels. San Gonçalo, the largest plant in Latin America, and our first client has more than 4 million panels. That can take a long time to be fully inspected, bring operational risks, and causing revenue reduction due to energy production loss. Understanding which panel needs adjustment or maintenance became a complex, costly, and sometimes even a dangerous activity. Well, but this is where Horus comes in. We offer a complete data capture and analysis solutions. Our technology uses Jones imagery to automatically, quickly, and safely find all anomalies in the plant, providing precise information to managers who can then carry out maintenance, making the asset much more efficient, safe, and reliable. Our technology already allowed more than 15 large plants in Brazil to become more efficient, increase their revenue, and consequently, the return of their investment. Well, the purpose we bring here today is for EGP to allow us to assist them in this process as well, using our 10 years of experience and expertise in remote inspections so that we can together make their solar assets even more efficient. The pilot can be here in Brazil or in any other country, as our technology is not only scalable, but can be replicated in any plant in the world. Together, Horus and EGP can find the best pilot configuration that allows EGP to obtain the maximum possible value from this experience. Well, guys, my name is Lucas, this is Horus, and I hope we can work together in this way, and in this way, accelerate the energy transition to renewable sources. Thank you very much. I'm very quickly in the pitching.
True, you still have, it's okay because then we can use it for Q&A.
That's my point.
Who has questions for Lucas?
Maybe I can start. So hi, Lucas, and thank you for your pitch.
Thank you.
I'm not sure if you mentioned, but what type of issues are your solution able to detect?
Right. So the main anomalies that we... Oh, sorry, stop to share my screen, right?
No, I can see it.
Okay. So the main issues that we are seeing through the drone imagery are hotspots, diode failure, track misalignment, vegetation, open strings, or any kind of anomalies that can be present in the different kind of configuration of a solar power plant.
Okay. And so you are able to classify these type of issues, and then are you able to send alerts to the operators with a proposed solution?
Exactly. So after we scan the whole asset, we process the imagery, and then our algorithms can identify any anomaly, and we understand the loss, the effect of this production loss of any anomaly. That correlates to this very detailed spreadsheet and this platform that allows the manager to understand the distribution of these anomalies in their asset. That basically brings to one unified solution, and one manager can actually manage many other different solar power plants, you know?
Okay, thank you.
Oh, no problem. Thank you.
Lucas, I have one or two questions, and thank you for the presentation. What is your business model? So do you charge by report, by number of assets inspected? How does that work?
We charge for the megawatt spike installed, so the potence, the size of the plant, basically, you know.
Okay.
So it can vary from the size of the power plant, so or even the recurrent inspections that you have interest into.
Okay. And for a pilot project, what would be the ideal scenario? So capacity of the solar farm, what would be an estimated cost for these? What's your thoughts on a pilot project?
Well, so we start all this technology in one of the largest plants of Latin America. I actually showed the picture, San Gonzalo. And I know that EGP has one plant in São Paulo. We could do that demo with absolutely no cost. All we need is probably sign an NDA to have access to the asset information. And then you guys can actually have full access to our technology, no problem at all. Our main goal is to minimize any barriers to you guys have access to the value that we can bring to you.
Okay, clear. Thank you.
No problem. For a minute, guys.
Hey, Lucas, thank you for your pitch.
Hello.
One additional question. What is your track record in Brazil so far? And do you have any projects outside of Brazil so far?
Right now, we just worked in Brazil. We have a very close relationship with CGNBE, NOX. Comerc is a huge company in Brazil in centralized generation. And last year, we start running the same technology in decentralized generation. Oh, that means like smaller plants. And the whole goal here actually is to understand how mature are these companies. Any kind of company has different mature in using drones as data capture. And our mission here is helping these different mature companies to actually receive the same value. So if the company has like a pilot drone program, they can use their own drones to capture the data. Of course, we help them to understand what the height, what the overlap of the images, so they can actually extract using our software the whole value. But we have like since 2018. I think I have even one. Okay. We map more than 7 gigawatt spike in 1 year. So we have like we have big experience, huge experience actually in different kind of configurations of solar, you know.
Okay. Perfect. Thank you very much, Lucas.
Thank you.
Okay, that's it. Thanks a lot, Lucas, for your presentation.
Thank you, guys.
Yes, that's it. We'll get back to you with the results in the next few weeks.
All
Okay.
right. Thank you. Have a
Thank you.
great day. Bye-bye.
Okay, next we have Kalika, who's going to present SunGreen H2. Hello,
Hi everyone, I'm Tulika Raj from SunGreen H2. Nice to meet you all.
Kalika.
Hi, can you hear me?
You're muted.
I
I
can hear
can
her.
hear. Yeah,
Yeah,
me
also.
too.
It
seem
should
like
be something on your side, Margarita. I think Margarita is the one not hearing us. One second.
Yeah, sorry, it was my internet. Hi, welcome,
Hi,
Kalika.
thank you so much.
We are here with EDP and we are ready to hear your pitch. So you can go ahead and share your screen. You have 4 minutes.
Thank you so much. It's a pleasure to be here today. I'm Tulika Raj from SunGreen H2. I'll let the next 1-minute video introduce myself and our company's technology, and then I'll switch into some slides if that's okay. Please let me know if you cannot see and hear my screen. Starting now. Everything that can be electrified must be electrified. When you cannot use renewable electrons, which are now cheap, that is the time to turn to green hydrogen. My name is Tulika Raj, and I'm co-founder and CEO of SunGreen H2. Green hydrogen production from electrolysis has been around for over 100 years, but it takes a lot of energy and expensive materials like platinum and iridium. So what we have is a nanostructured electrode using no precious metals. These electrodes have been carefully engineered using nanotechnology in order to double the surface area available for the water splitting reaction and reduce the energy consumed in the process by 10 to 20%. The technology is under patenting. We think this is a scalable and sustainable way for the industry to realize the hundreds of gigawatts of growth coming for it.
Powering tomorrow in association with IRENA.
Many thanks to CNN and IRENA for featuring SunGreen H2's technology. As we just saw in the screen previously, SunGreen H2 is a company that is supercharging electrolyzers so that orders more magnitude of hydrogen can cleanly be produced from water. We have been recognized internationally for our award-winning approach to improving the adoption of clean hydrogen by lowering its cost. A brief background on the company, we are working with marquee name investors and partners to scale up a groundbreaking approach to electrolysis using nano-engineered electrodes, and being headquartered in Singapore with operations and R&D spanning all the way from Southeast Asia to Australia, we are well positioned to be supplying the global electrolyzer market. Here we see that a small snapshot of SunGreen H2's manufacturing capability from start to finish, electrodes to stacks to complete system. What is our unique value proposition? The highly nano-engineered electrodes that we make offer lasting performance for decades, where stack performance like alkaline electrolyzers is guaranteed for a decade plus, and this is using a newer AEM technology. In all cases, we are doubling the hydrogen production by being able to run at increased current density, the electrolyzers themselves, and reducing energy consumption by 20%. We don't use any precious metals in our technology and have extremely stable performance with less than 1% degradation over every 1 year of performance. Everything from the components to the stacks are compatible with high throughput industrially manufacturable processes. Here I share some technical data for non-precious metals based AEM electrolyzer stack built entirely by SunGreen H2 using our own components and electrodes, running at close to 88% HHV efficiency. And in further iterations, we expect to take this to 90% plus. The impact of our technology is to reduce the levelized cost of hydrogen by both reducing the capex and the opex, leading to, even at our small volume batch production process today, a 40% reduction in the produced cost of hydrogen. And we believe that we can reduce the cost of our stacks by over 10x over the next couple of years. Here are the complete turnkey electrolyzer systems that we are delivering into Europe with our partner Naturgy in Spain, and we look forward to bringing the technology with partners like EDP further afield. We are also releasing megawatt scale electrolyzers at the end of this year for deployment in 2025. A number of the clients that we're working with are in Spain, Italy, Turkey, Singapore, Australia, and further afield as far as the Americas, including Chile. Some of the use cases for the electrolyzer, to which we're very agnostic, are shown here, where our current clients are using the electrolyzers in everything from methanation, refueling, blending, and microgrid projects. The technology is modular and scalable to the gigawatt size, as I mentioned, and the company has been on a fast track over its 3 years of existing, scaling from electrodes to stacks to megawatt scale systems, working with marquee names in all cases, and partnering up to commercialize fast. Here is a snapshot of our team and our advisors, and some of the partners that we're also working with in order to bring different aspects of the technology to market faster. A snapshot also of the awards and recognition that we've received, and look forward with that end to receiving your questions.
Thank you, Tilika. So now let's go for Q&A. Who has questions? Pedro, go ahead.
Hello, thank you for your presentation. We are curious about your stack. So in terms of capex, can you justify how you can achieve the 50% lower than PEM? If I understand correctly, you are AEM, right, instead of
Correct.
PEM. And
Correct.
if you can go into detail of what do you use in your catalysts that makes you achieve that that big reduction in capex, but at the same time, you show very good efficiencies. But what about your degradations over time? How can we know in the long term the comparison between your results and PEM? And also the question of do you have a patent already in this technology or okay?
Okay, thank you for the question so much, Pedro. Let me explain a little bit more about the technology background. So let me start from fresh, and the electrodes that we are making are using just nickel-based materials. The company's technology is actually to make these nano-engineered electrodes. We are supplying these components as electrodes only to existing alkaline and PEM OEMs. In other words, we can supply components only. For the stack that we have prepared, it is using our own AEM electrodes. We believe that AEM is the technology of the future, and we are showing extremely good performance without using any precious metals. The positioning of the electrolyzer is such that we are offering higher efficiency and longer lifespan, 10 years for the stack with minimal refurbishment of membrane in the middle, and a system that will last 25 years and using only alkaline type materials. So it is a nice combination of the existing alkaline and the PEM technologies, eliminating the issues. Why do we not have any degradation? This is a very important question using the catalyst that we do. One, we have patents filed in multiple countries, 8 different countries, and global multiple patents on the PCT side as well. This is spanning everything from the super alloy material that we create for the catalyst, all the way to the deposition process for creating metallurgically fused nanostructures. In other words, our technology approach is quite different to the PEM, where there is a CCM technology and the ionomer binder is eventually dropping off the catalyst in about 4 years, requiring stack replacement. In our case, we are operating for a decade plus with minimal degradation of the electrodes. We have seen in testing, both internal and external, less than 1% degradation over 10,000 hours of operation. Happy to share that data. And we have done this testing for our electrodes for over 40,000 hours of accelerated testing. And currently our stack testing is already crossed 20,000 hours and going for 40,000 hours of accelerated testing. I also showed you a system picture because we are now going into field trials with clients who are actually deploying this electrolyzer in real life use cases in the field. And so that data is also starting to become available. We also have clients for the megawatt scale electrolyzer. We manufacture our stacks in 3 sizes, 2 kilowatt, 20 kilowatt, and 100 kilowatt. And these 3 sizes allow us to address sub-megawatt, megawatt plus, and megawatt plus plus to 100 megawatt size electrolyzers. So this is how we are scaling up the technology. In terms of catalysts, we have a superalloy structure and we do not use any precious metals inside at all. I don't know if I covered all your questions, but if I left
You
out,
do. It
I
seems
apologize.
super interesting, to be honest, and the values that you are sharing seem very good, better than the industry. So I would like to
These
see
figures have been shared
lab tests.
in an industry forum at Fraunhofer's sixth alkaline electrolyzer conference very recently at the end of last year. So it's very good data. We're actually working for external validation of our materials with Fraunhofer as well. So
Just one last question. You mentioned 25 years of life, but not for the stack. It's for the stack?
For the system, it is 25 years. Minor maintenance in 4 years for membrane refurbishment. Major maintenance for stack refurbishment in 10 years, but yet to be seen because we believe it will last longer. We believe the electrodes will last even longer than 10 years.
Okay,
so we will see if it is a minor or a major refurbishment at that point.
Very interesting. Thank you.
Thank you.
I can make a quick question. Hi, Tulika. Thank you very much for your presentation. You present here these values at stack level. What would be, for instance, the electrical consumption at system level that you would get, and what would be the purity and the pressure of the hydrogen outlet production?
Thank you. First question, the BOP added on to this is a 5% extra consumption on power. So we had a very optimized, very efficient BOP, leading for the 45 to turn into a 48 kilowatt hours per kg at the system level. Right now, we actually have a higher efficiency of about 42 kilowatt hours for our current generation of 20 kilowatt stack, which means that the system level efficiency is also ends up being around 45 to 46. So it's under 50 kilowatt hours per kg, even including the BOP, because it is only a 5% consumption of the overall power. That's on the system side. What was your other question? Sorry.
It was the outlet pressure of hydrogen and the purity.
99.9 till 999%. Right now, we are actually revenue generating. We are supplying electrolyzers. We often offer a fuel cell grade purifier in addition to dry off some water vapor, but otherwise the purity is 99.9. And the other 0.1% is just water vapor. So we just offer a dryer as an additional option if you want to dry to fuel cell grade purity. The pressure, it's coming in two types of pressurized systems. One is less than 10 bar pressure, which we supply into markets like Japan, whereas you know the regulations are a bit different. And there is a launch of a 35 bar pressurized system as well that we are undertaking.
Thank you very much.
Welcome.
Okay, thank you so much, Tulika. We ran out of time, so thank you. We'll keep you updated. We'll let you know the results in the next few weeks, okay?
Thank you, everyone, for your time. Nice to see you again. Bye-bye.
Thank you. Okay, so next we have Anders, who's gonna present element 1. Hi, Anders.
Hello.
Hi, welcome. We are
Thank you
here
very
with
much.
EVP, and we are ready to hear your pitch. So you can go ahead and share your screen, and you have 4 minutes to pitch.
Thank you very much. So can you see my screen now?
Yeah, we can.
So thank you very much for this opportunity. My name is Anders Kvåle. I'm the CEO at Element 1 Energy. We enable cost-effective hydrogen production with a novel centrifugal force electrolyzer. Green hydrogen is expensive. In this example, I will show the cost of compressed hydrogen with PEM matched with intermittent renewable energy at low electricity price. Still, you see that the cost of electricity is the majority cost in addition to compression cost. We have a novel electrolyzer and fuel cell technology using centrifugal force. We can do it with both PEM and AEM, but we start with PEM electrolyzers. When we increase the rotation, we see a drop in power, at least 15 percentage points efficiency improvement compared to PEM state of art. We also do it with high pressure, so we can remove compressors. Since we have very good separation due to the centrifugal force, we increase the power density and can reduce the material usage. This effect also results in minimal use of critical raw material. If we remove need for compressors by using high pressure electrolyzers, reduce capex with 30% because of higher power density and compactness, improve efficiency by 15 percentage points. In combination, this is resulting in 30% lower hydrogen production cost. If we do a POC with EDP, 200 kilowatt electrolyzers with a strategy for reduced hydrogen production cost, we can look into a turn down and on-off mode on a solar wind energy fluctuation scenario, whatever EDP would like to do, resulting in a low electricity cost. We can also do it with high pressure, 80 bar, or according to requirement for EDP. And we can use our own low critical raw material loading strategy, or use cooperate with a partner and use another catalyst. We have a strong experience, our team has a strong experience in engineering, procurement, and construction projects, and we know what it takes to develop such projects. We have a strong academic and research background, and I believe in one team philosophy with EDP, academia, and partners, where we can collaborate from all phases, from research to construction. This will give a good fundament for execution of a 200 kilowatt POC project, where we see the cost will be approximately €1 million, and we can match that with EU or local grant schemes. So far, we have been incubated by local incubators, worked together with local universities, and done several R&D projects, where we have matured the technology to 45, and we're bringing it to TRL 6 this year, and making it ready for a POC projects together with EDP, where we're targeting TRL 7. After that, we can also then be ready for a full-scale pilot at 1 megawatt. So, thank you very much.
Thank you for the presentation. So now let's go to the Q&A. Who has questions for Anders? Pedro, go ahead.
Just a quick question. So if I understand correctly, your main advantage is we save the capex in compression and also the energy in compression. But what are the trade-offs? I mean, if your electrolyzer can achieve higher pressures, I imagine it must have a bulkier components. So what is the trade-off, and how is the capex that you expect comparing to the traditional solutions in the industry at the moment?
We have both reducing, improving the efficiency, and also reducing the cost of compressors. The capex cost is not increasing because it's not that bulky. It's a bit additional stainless steel, but it's not any significant cost increasement. And also how we are rotating it is not very costly to rotate it. So in summarize, it will not add the capex significantly.
Okay. And why do you achieve much better efficiency? What is the driver for that?
It's about concentration in the catalyst surface. So you are actually improving the concentration difference and separation at the catalyst interface.
But do you have precious metals there, or
yeah, it is. We can use different types of catalysts. We will use the best available catalyst. We have our own catalyst development also, but we can in general use any kind of best available technology within the catalyst.
But that would that would be the same for the incumbents, right? So what is the differentiating parameter there that allows you to get more efficiency?
The differentiation is that how we have a proprietary technology, how we're doing the rotation, and how we are actually achieving the separation at the catalyst surface.
Okay, understood. Thank you.
Hi, what's the expected lifespan of the membranes in terms of hours, operating hours?
The membrane is about the same as traditional membranes, the technology, PEM technology. But when it comes to catalyst, we expect actually improved efficiency. We have not tested it in long term, but based on what we expect, we will remove some of the degradation mechanisms. So it's especially good for on and off operation because we're removing some of the degradation mechanism, and therefore because now it's not a lot of degradation because of on-off, we can do it without that high degradation. So we don't have not any measurements yet on that, but we expect better.
Okay, thank you.
Hi, Anders. Thank you for your pitch. May I ask you, are the membranes subjected to a higher pressure difference? Does that affect the degradation? How does that work? Can you give us some insight on that?
We are using low differential pressure, high pressure, but low differential pressure. So we can reduce the thickness of the membrane. And also because of how we are doing the separation, we reduce the crossover problems with regards to when we're having high pressure. When it comes to the lifetime, it's, as I mentioned, we expect a bit the same as traditional electrolyzers.
Okay, thanks. Okay, I think we ran out of time. So Anders, thanks for your presentation, and we'll let you know the results in the next few weeks. Okay.
Okay. Thank you very much. Bye-bye. Thanks.
Bye. Bye. Okay, so we have the next startup before the break. The startup is Vision 2H, and we're gonna have Maximiliano and Dario here. Okay, hi Dario. Hi Maximilian. Hi. You're on mute.
Okay, good morning. Yeah. Now the audio is on. Okay.
Good morning. Welcome. We are here with DDP and we are ready to hear your pitch. So you can go ahead and share your screen and you have 4 minutes to pitch.
Okay. So do you see our presentation in full screen? Okay, perfect. So good morning. We are Vision 2H, and just a second, I have to move. And we build AEM electrolyzers for sustainable and affordable green hydrogen production at scale. This is our peculiarity. And we have identified 3 challenges to the success of green hydrogen in the market. Number 1 is that we do believe that to reach global decarbonization, green hydrogen technology must be developed at scale, because we think that small size production units cannot have a real impact on net zero goals. The second is that to secure its role as the clean energy vector for the future, the green hydrogen environmental impact must be minimized. This is because some of the current electrolysis technologies considered as green are in fact still having some environmental impacts. The challenge number 3 is that to represent a real game changer, green hydrogen price must be reduced significantly. In fact, apart from political or advertising slogans, price will be the real parameter to determine the green hydrogen success compared to the gray one. Okay. Our solutions to these three challenges are, the first one is that Vision 2H is currently building its first 100 kilowatt single stack AEM electrolyzers as a first step. You may know that AEM electrolyzers right now on the market are very, very small in stack units. Our stack technology development plan will enable us to deploy turnkey AEM electrolysis solution at multi-watt scale by 2026. This is our developing program for the AEM technology. Then Vision 2H AEM technology operates with pure water or very, very low concentrated alkaline environment, which is winning against alkaline systems, combined with reduced or zero PGMs content and FPAS, also named as forever chemicals, which is a winning point against PEM actually on the market. About the price, combining low design complexity, operational flexibility, rational use of natural resources as PGM, and being developed at big scale, Vision 2H AEM electrolyzers represent versatile, sustainable, and affordable green hydrogen production solutions. Our pilot proposal is about this project. To achieve our multi-megawatt scale target, we have established a clear development pathway, which starts from 100 kilowatt, as I said before, for 2024, and will reach the megawatt scale in 2026. Our system will operate at 30 bars and are capable to producing 500 kilograms of hydrogen per day for every megawatt installed, with a purity grade of 5.0. Okay, so only our pilot, which is scheduled for the end of this year, will produce 50 kilos of green high purity hydrogen per day. About our pilot, we are currently finalizing the design of the balance of plant and initiating the production. Our single stack 100 kilowatt prototype is expected to be operational by the end of this year. We are seeking a pilot project to install our anion exchange membrane electrolyzer end of this year. This will allow us to validate the technology and compile a proven field data package. This is what we are looking for. So about the call to action, we ask you to join Vision 2H in advancing AEM technology to the megawatt scale and to become our developer partner by integrating our prototype in your eventual pilot project. So we are asking you which is your hydrogen vision, and we thank you for your attention. I do hope I remaining in time.
Thank you for that, Dario. Okay, let's go to the questions. Who wants to start?
Yes. Sorry, Pedro, you first.
Thank you, Luis. Just a quick question. If I understand correctly, you still don't have a prototype working, right? So what do you expect in terms of efficiencies from this first prototype, and what is different from the AEM companies that are already trying in this field?
Okay, yes, just a second. I reopen for my... Okay. So compared to actual electrolyzers, AEM electrolyzer manufacturer, our peculiarity is the scale, okay? Because as in the market, AEM are only in 2.4 kilowatt size. We are starting from 100 kilowatt, okay? And we are developing the scale up to 1 megawatt for the next year. And so the production is comparable to PM production. Also the purity and also the pressure of the BOP is analog to PM, but with a very, very low concentration of water or of alkaline in the water. We are speaking about 0.01 molar KOH in the water. And also we are co-developing with the membrane manufacturer to go to zero electrolyte. Okay, and this is a peculiarity of our system. And then, of course, being an AEM, there will be no PGM or close to zero PGM content in electrodes. And so we are combining big scale with the low concentration of alkaline, very, very low, and also very, very low concentration of PGM. and total absence of forever chemicals compared to PEM.
But do you have an expectation in terms of efficiency and degradations? Because from the AEMs in the market, the problem normally is the degradation. So
efficiency, you know, there are many methods to calculate efficiencies, and so it's between 65 to 70% at the moment. And degradation is another point. We have guarantees because we selected the membrane manufacturer and supplier for the data they provided for degradation. But of course, this will be the main scope of the pilot. So to put our pilot in place, and then to test the durability of the system, and particularly the membrane. This is the biggest challenge, of course, in our development. We are designing BOP in accordance to the performances we have by instrumental data on the membrane and the stack, but we have to validate it while a long-term execution of the pilot. So this is why we're looking for a pilot project in which to put our prototype and to run it for a long-term testing.
Is it a proprietary design? Do you have patents on it, or?
We are patenting the BOP, of course. Of course, all the BOP is under all the intellectual properties is our. Okay. About the stack, we are co-developing the stack with the membrane manufacturer, which is designing the stack to be in line with the performances of the membrane. So we don't have the technology to develop our membrane and so our stack. So we decided to start from a certain data, because to take a membrane development by ourselves will take years. But we will.
The catalysts you are taking from the market as well, right?
Yes. Of course.
Dario, good morning. Do you have any connection or any link with Enapter, the other Italian AEM manufacturer?
Let me say the only connection is that one of the persons which is in the design team is coming from Enapter. Okay. So he worked previously in Enapter, but this is honestly the only connection we have with them. We have connection with others, which are also trying to scale up the technology, but not with Enapter. Because we think that their let me say, way of thinking of the size of the stacks is a little bit out from our range.
Okay, thank you.
You're welcome.
Okay, we ran out of time. So thanks a lot, Dario and Massimiliano. Thanks for your presentation. And we'll let you know the results in the next few weeks, okay?
Okay, thank you very much. Have a nice day.
Thank you.
Have a good job.
Bye.
Bye-bye.
Bye-bye.
Okay, let's go for a short break, 10 minutes, and then 5 more startups and we're done, okay? Okay, see you in 10.
The key that I won't forget, you're lost in Paris. I hope that you're warm and safe. The memory that I can't replace, but you're lost in Paris.
Young, all in love in a lost place. Goddamn, got me running around in a rash race. Say grace, Lord, I fell in love with a small waist. Let me start, yeah, right, yeah, bang, shot me in my heart and it hurt case. She's so fly like a dove, that's a dove face. Don't know where she at now, but it's in her birthplace. Tom, don't tell her, but it's first for
I know that I need you now. The key that I won't forget, but you're lost in Paris. I hope that you're warm and safe. That I can't replace, but you're lost in Paris. I know that I need you now. The key that I won't forget, but you're lost in Paris. I hope that you're warm and safe. The memory that I can't replace, but you're lost in Paris. I know that I need you now. The key that I won't forget, but you're lost in Paris. You're lost in Paris. I hope that you're warm and safe. The memory that I can't replace, but you're lost in Paris.
Hello, is everyone back?
Hello.
Hello. Okay, I'm gonna start calling the next startup. So we are almost at the end. I know it's very intense. So we have 5 more startups to go, and the next it's H2 Vector. And João, you can let Miguel Angel in.
Hello.
Okay. Hi, welcome, Miguel Angel.
Hi.
Hi. We are here with you, and we are ready to hear your pitch.
Okay.
So yeah, go ahead. You can share your screen, and you have 4 minutes to pitch.
Okay, thank you.
Yeah, we can see it.
I don't know if you can, just 1 second, that it was in another screen, so I'll move it here. Can you see it?
We see the PowerPoint. Can you put it in presentation mode? No, we see the
We're seeing
other.
your notes. You need
Yeah.
to put it on.
Can you see the presentation or not?
No, you're in presentator mode, so what we see is your notes.
Okay, just 1 second. I will shift it to the other screen and
No worries.
And maybe you will be able to see it.
Yeah, all good.
Exactly. Now it's perfect.
Okay, thank you. Thank you. Sorry for the delay. Well, I'm ready to start whenever.
You can go ahead. 4
Okay,
minutes.
thank you.
Yeah.
Okay. Yep. Well, thank you for the time. And what I'm here to discuss is that by 2040, 6 out of 24 hours of energy will come from a storage solution. So we have a huge infrastructure challenge to attend. And my name is Miguel Angel Ocando, and I'm the CEO at H2 Vector. And what we build are energy solutions to decarbonize professional applications. Today, we are attending who we call the golden triangle of early adopters. We're talking about 3 types of businesses. And these current consumers are going to become prosumers, and they share at least one of these 3 features. The first one are critical facilities, like a hospital or a train station. The other type of customers that we're looking to attend are customers highly aligned with the ESG goals, and that they want to be drivers of the climate fight. And the third type of customers are customers that have already in place renewable assets on their facilities, and they would like to maximize well, basically the opportunity that those renewables brings to their business. And what we do is that we build a power-to-power solution. We call it, it's a mix between a battery and a genset, and features the electrolysis process, the compression process, and also a fuel cell. So what we get, it's compressed hydrogen, which means a small footprint in terms of energy and a high energy density. And we also feature high flexibility in order to bring back that energy stored to the system as electricity, also heat, and also compressed hydrogen for stationary and mobility applications. This is the most powerful slide that I can show you. These are demo sites and projects that we have already launched and that we developed back in 2023. We're talking about projects in 3 European countries that showcase our smallest product, the Vector 10 from our Vector series. And we know that we are competing against our main competitor is basically lithium batteries. And I would like to leave you with two facts. The first one is that
but for an equivalent lithium system, our solution has half of the CO2 footprint. And the second one is that if the application autonomy, it's 24 or more hours of have a 24 or more hours necessity in terms of autonomy, our solution is more profitable than the lithium option, even being manufactured in a small quantities in a really artisanal way, like we do it today. And the second type of let's say our differentiation with other manufacturers that build similar things to us is that we are ready to attend the battery electrical vehicle mobility, the BEV, and we're also ready to attend the next type of mobility that it's set to come, which is the one proposed by hydrogen fuel cells. To leave you a little bit with our let's say what we have achieved, we have sales that already we're closing to 600,000 case in sales. We have a pipeline for 2024 of more than 300,000 euros. And we have already secured also grants for above 600,000 euros in order to develop key R&D projects for the future of our company. These key R&D projects are related with the mobility and large industry applications. And on this slide, I will be very brief. Similar applications to ours, like fuel cell gensets and fuel cell vehicles, are set to have a continuous annual growth of more than 25% by up to 2030. And some of them are set to reach the $1 billion marks. Of course, these are forecasts, and we need to work in order to make them actually to make them work. At H2 Vector, we are a diverse and multicultural team. We have our core team, it's based on engineering abilities. And we share the same passion, which is to build energy solutions for our customers. And regarding the EDP demo, basically what we're proposing is to attend power plants, traditional power plants. And with hydrogen, we can attend to two type of uses. The first one is to attend the hydrogen makeup that are needed on large generators, which are cooled with hydrogen, and that you can build that hydrogen on site. And the second use for our same device, for our Vector 10, for example, or a bigger one, a larger one, will be to use the remaining hydrogen, which is not used as a makeup, to provide electricity and heat, and in this case, especially electricity for critical systems that you will have on the facility. So that it's more or less the use case that we are proposing to you, to use hydrogen as that you are already using on different sites, that sometimes is brought and purchased outside of the facility to build that fuel on site, and to have that green hydrogen and that differentiation factor in your facility. And on my side, that will be it. Thank you for the time.
Thank you for the presentation. Okay, now let's go to the Q&A. Who wants to start? Pedro, go ahead.
Make a quick question. In the graph where you show the crossover between the hydrogen and the batteries, is it taking into account also the energy loss that the vehicle will have, or just the energy delivered to the vehicle before its internal losses?
Basically, the graphic on the top side of the slide, it's the one that it's considering the vehicle, or a close to a vehicle comparison, where we take in account the hydrogen production and also the vehicle use. So everything is considered on the CO2 part. And in the lower part of the slide, we're talking about traditional batteries on stationary applications. And on this case, we're talking about energy autonomy. So let's say that when the application has more than 24 hours of autonomy, let's say long-term storage, our solution today, it's more profitable than the lithium-based one. We basically, separating energy management, like hydrogen production and also electricity delivery, to storage. We are able to separate these three processes, which on traditional lithium batteries are all done together. So when you want to increase on autonomy, you have to increase also in energy management, which means that a traditional battery scales really poorly, let's call it somehow, and we are able to scale on maximizing what we need. If we need more power, we're going to scale on the power part. If we need more storage, we're going to scale on the storage side.
But this is just for the vehicle parts, right? It does not take into consideration the electrolyzer, the electrolyzer mainly. Because your solution has the three parts, right? It has the electrolyzer, the compressor, and then the storage and fuel cell. But here we are talking just about the vehicles with the fuel cell and storage only, right?
In case of the CO2 and also in case of the break-even point, both taking into account the electrolysis, takes into account the compression part, takes into account the storage, and takes into account also the fuel cell. So, and also for the CO2 study, we also take into account the energy in order to produce it, and then also the energy and also all the considerations on CO2 footprint in order to recycle the material after it's the operational life cycle, it's already let's say consumed.
Thank you.
I have one question, and thank you for the presentation. For the demo sites that you were mentioning, what would be the ideal capacity for this pilot project, and what kind of capex are we talking about?
Yep. On this case, the smallest device that we produce, it's our Vector 10, which have half a kilowatt per day of hydrogen production. This is taking into account that we'll be only using renewable energy that you could have in the facility to build that hydrogen. So that's half a kilowatt, a kilogram per day. More or less, I come from building power plants in my previous, let's say, jobs, and similar solutions for 300, 450 megawatt generators. They had a makeup system on site. The only one that I saw that was 2 times the nominal capacity of the demo that we are going to be proposing. We can increase it, but that will increase a little bit the capex. And in terms of the electricity side, we have seen that DCS systems and let's say power modules that we use that you can use on a gas turbine, for example, on a 50 megawatt or 200 megawatt gas turbine, you will have a consumption around 25 kilowatts that are going to be, let's say, on the UPS side or the safety side. In this case, our fuel cell, the one that we'll be proposing for the demo, it's going to be a 7 kilowatt, so it's going to help the system, but it's not going to replace the batteries that you will have that you will have in place already. So what we can do with a small demo, with a capex of around 65,000 euros, which will be the vector plus the storage autonomy. We can use the autonomy that the bottles that you will have on site, which are deployed already if you want, or we can include that part also. And that part, it's 12,000 euros, more or less a standard set that we have. And we can cover the makeup, more or less roughly the necessity, depending on the makeup amount that you will be needing, depending on the size of your site. And on the other side, we'll be covering part of the electricity that you will be demanding on the UPS part of the system. And our system has the advantage that we can deliver electricity on AC and DC, and we can adapt our electrical output into anything that you have on site. 1-phase, 3-phase, voltages between 24, 48, 72 volts, which are the standard voltages that you will have on site, and we can couple and synchronize really easy.
Okay, clear. Thank you.
Okay, so thank you a lot, Miguel Angel, for your presentation. We'll let you know the results in the next few weeks, okay?
Okay, thank you very much to all of you, and have a nice day. See you.
Thank you. Okay, so we're missing 4. Almost there. Next, we have Flexergy, sorry, with Paul. It's gonna be Paul presenting. So, João, you can let Paul in. Hi, Paul.
Hi, Margarida. Hi,
Hi,
everyone.
welcome.
Good afternoon, good evening, good morning. Really excited to be here. Thanks for your time and attention.
Thank you for being here. So we are here with EDP, and we're ready to hear your pitch. So you can go ahead and share your screen, and you have 4 minutes to pitch.
Fantastic.
Yeah.
Good
Go
stuff.
ahead.
Yeah, we're nearly there. This must be a marathon for you guys. So well done. But last batch. So we are creating what we believe is the most efficient and flexible gas compression system in the world. It's a hydrogen native technology platform which is easily adaptable to other gases. We're aiming for customer pilots in 2025. Will be profitable from 26, and we're looking at utility scale manufacture and deployment from financial year 28. Essentially, if you look at the compressor, which is the longest lead time item in a hydrogen project, here we are compressing a gas, in this case, air. When you compress a gas, it gets hot. And if you compress it quickly, it gets, even on a bicycle, too hot to touch at the end of the pump there. And that's only going to 2 or 3 bar. Imagine if you're going to 200 or 300 bar. That is all waste heat. And that's what we're targeting in our innovation, which allows us to do the compression in a very different way. So what do compressor companies do in order to combat this waste heat? Well, they build very large systems. This is a photo of 4 large compressors, and you can imagine, for example, there could be a 1 gigawatt electrolyzer in the next room in this warehouse, which is sending the hydrogen into these 4 compressors to compress and send into a pipeline, for example. If one of those compressors goes down, then that means the whole of the value chain, the electrolyzers, the pipeline, the compressor itself, the balance of plant, everything is lying idle while that piece of kit is offline. So why do they go to these big sizes? It's because compressors are inefficient, they're making waste. We have a much more efficient system, which allows us to build things in a very different way, which I'll come on to. So thermodynamics professors at University of Strathclyde are telling us that our system is 30% more energy efficient than what's on the market today. And in some cases, that's able to reduce the cost of hydrogen very substantially when we integrate that with storage and tube trailer delivery. So because we have a more efficient system, it allows us to have a large number of smaller compressors without sacrificing the efficiency that other compressor manufacturers do. That allows us to offer a 100% uptime guarantee, because if we lose 1% or 0.5% of our overall compressor manufacturing delivery capability, that's not the same as losing 25% or 50%. We can also, it's a small modular scalable system, which is faster to design, customize, manufacture, commission, and to repair. So we're targeting pipelines, cavern storage, and derivative fuel production, such as ammonia. All of these need compressors at the heart of their system. We're competing against mature incumbents with great industrial heritage. If we take Britain's largest compressor manufacturer, Howden, as an example, they're not able to do the things that we can do. So the differentiation that we have against all of these incumbents, that our system is modular, plug and play. We're offering this unique business model advantage underpinned by our efficiency. There are operational improvements, and we're faster to deploy. We're setting up as an IP owner and original equipment manufacturer. So our customers will be the engineering, procurement, construction companies, or the global companies that are servicing clients such as EDP and others developing hydrogen projects. So we're a very experienced team. My background, my previous role was founder and commercial director at a compressed air energy storage technology development company. And prior to that, I've had sustainable energy roles in the global copper mining industry. My CTO and co-founder is the former head of technology at AGEERA, which is a distributed power company, manufacturing power equipment and exporting globally. And he's also former head of the Advanced Concept Center at Rolls-Royce. On our board, we have Professor Ian Arbin, who is the former managing director of Britain's largest compressor company. And he has 50 years experience as an engineer in compressing hydrogen. So we have a patent pending technology. We're externally validated. An experienced team. We're developing a global customer pipeline. We can help companies and projects to reach FID faster and at lower risk. It's a more bankable project. And we can lower the levelized cost of hydrogen. So the next steps for us, we have a proof of concepts system which is being built right now. That we'll have experimental results from that very soon in the next couple of months. And by the end of 2024, we'll have a prototype, a full system prototype. We're also looking for EU grants and feasibility studies and so on. So there's lots for us to potential collaboration. And I'll just wrap up with this, that it was not the invention of the steam engine which precipitated the first industrial revolution, but it was when it was made more efficient. Thanks very much.
Thank you, Paul. Thanks for the presentation. So now let's go for the Q&A. Who wants to start? Go ahead, Pedro.
Just a quick one. I understand the reasoning behind what you are proposing. So we have a better compressor, more efficient, less cost. But can you talk us through what is different in terms of design? What are the main differentiating characteristics? I believe we didn't see much about that.
Yeah, absolutely. So essentially, we are handling the heat in a novel way. And that means that normally when you compress hydrogen or any gas, you compress it, it gets hot, then you cool it down in an intercooler, then you compress it again, it gets hot again, you cool it down. And so it goes through this thermodynamic cycle, which has irreversible losses in it as it goes hotter and colder. And what we are doing is we are keeping the temperature very similar as it goes through that compression cycle. So that's called isothermal compression. When most compressor manufacturers measure their efficiency, they talk about isentropic efficiency, but we are on a different scale. So we're starting from a much more efficient place. So we are getting to near isothermal compression. There are some parasitic loads which bring our efficiency down. It's not actual, full isothermal, which is the maximum theoretical efficiency that we can get. But even accounting for those loads, we're 30% more efficient than what's on the market today.
But how is that achieved? How can you compress and keep it at the same temperature?
So we have a patent pending on that technology, but the patent hasn't been granted. It's going through the patent process at the moment. We filed it in May of last year. So it's going through that process, and until we are further down, we're not able to talk about it without an NDA in place. But what I can say is that it's a reciprocating compressor. So it's very good at high pressures, very good at doing large loads.
Thank you.
Someone else? George, go ahead.
Yes. Hi, Paul. Thank you for your presentation. Quick question about the CapEx of your solution compared to the other alternatives. Do you have any insight that you could share with us?
Yeah, so we're targeting a mid-price CapEx. We actually believe that it's going to be cheaper for us to manufacture than other systems. But what we want to do is make sure that we capture some of that value to build a rapidly growing business. So we're targeting a mid-price CapEx and a mid-price OpEx. Now, of course, we've got this efficiency, which really brings down that OpEx. But actually, what we think is that the 100% uptime guarantee and the bankability of the project, so those two USPs, if you like, actually give us a real unique edge in the market, which is going to be very much worthwhile for customers to pay a mid price, even though we're more profitable than a comparable compressor company would be at those prices.
And what would be the ranges of flow rates and pressures that you are targeting?
So we are looking at different product ranges. So, for example, for pipelines, for cavern storage, for pipelines, we're looking at somewhere between 70 and 120 bar. For cavern storage, we're looking at somewhere between 200 and 300 or just over 300 bar. But the technology platform can be configured into multiple projects, and that could be, for example, for 1,000 bar or beyond. There's no limit. The 30% figure, it's worth saying, is based on a 700 bar system. So, and the higher the pressure, the more we're able to differentiate in terms of efficiency.
So then in flow rates, do you have any target
In
values?
flow rates, we're looking at per 40-foot shipping container, 300 kilograms per hour. But again, that's based on a kind of HRS level system.
Understood. Thank you.
Okay, so we ran out of time. Thanks a lot, Paul, for your presentation, for your time.
You're very
We'll let you
welcome.
know the next few weeks, okay?
Thanks, Margarita. Thanks, everybody.
Thank you. Okay, 3 to go. Almost there. Now we have Advanced Ionics, and we're gonna have Chad presenting. Hi, Chad.
Hello, can you hear me okay?
Hey. Yeah, welcome.
Yeah, thanks.
Yeah, we are here with EVP and we are ready to hear your pitch. So yeah, you can start and you have 4 minutes.
Sounds good. You should see full screen now. I'm Chad Mason, founder and CEO of Advanced Ionics. All right, so I think everyone here knows how much emissions come from heavy industry. So hydrogen itself causes about 3% of all emissions, and then adding things like steel in, hydrogen can abate about 10% of all emissions worldwide. So where it's used today is really just a few things: petrochemicals, ammonia, and then in the future, green chemicals, green steel, things like that. So when someone tells you they have a better electrolyzer, you should be very skeptical. They've been around a very long time, for 100 years, such as this alkaline system right here. And the reason is quite simple: is electrolysis, in contrast to other industries, is really dominated by OpEx. So even as you take out CapEx, OpEx dominates even more. So we basically go to the heart of OpEx, and that's reducing stack electricity requirements down to about 35 kilowatt hours per kilogram using water vapor electrolysis. So you could think of, if you put up a solar farm or a wind farm, you need 30% less solar panels, or you can allocate 30% of them to grid services or other money-making projects. So what's the number 1 and 2 rule of talking about of transporting hydrogen is don't talk about transporting hydrogen. The reason is because it's very hard to do and it adds a lot of expense to the end product itself. So this is why hydrogen today is always cracked on site for methane and immediately fed into the industrial process. So we believe electrolysis should be done the same way because that's physics. So we've developed an electrolyzer that has really great synergy with all of these industrial processes. So we do this starting at the stack level, no expensive rare materials, system level, off-the-shelf components, plug-and-play balance of plant that we're designing, and with our partner on the power supply side, which is the highest efficiency units that you can basically get. So when we work with folks internally, we call that the early access program. And so we always look at a partnership that comes to the heart of these things, decarbonization of chemicals, green fuels, and other things that are transport vectors for energy and molecules. And so we look at that with our direct partners or other partners in the coalition to create a big win-win. We have a lot of flexibility as far as pilots are concerned and demonstrations. So that can be a single 50 kilogram per day module that's done even at our site to provide data. It can be done at someone else's site without thermal integration, or you can have full thermal integration. So we have a lot of flexibility to scope out a project. So there's possibilities to move faster and sooner, and there's also possibilities for much larger units down the line as well. So what we really see is we want folks to come work with us, help create this beautiful future of, industrial hubs and clusters where we have all of these processes producing clean, sustainable materials and things we need in the future. And we're going to be at the heart of enabling that, replacing steam methane reforming. So come join us and partner with our team, which is about, over 25 people now, most of us in Milwaukee, Wisconsin. Except for a couple people in Houston and elsewhere. And really, it's a wonderful place to do this work. It's the heart of manufacturing in the US, where many of the things we take for granted are made. So really big thanks for having myself and Ignacio on today, and happy to answer your questions.
Thanks a lot for the presentation. Okay, let's go to the questions. Who wants to start?
So I can do one. We already spoke before, so I won't do many in-depth questions because I already had the chance to do that. But maybe just a more general one. What, in terms of your roadmap to make a commercial unit, what do you see that are the main challenges, and in terms of supply chain and the cost of the materials, what is the biggest bottleneck that you may find?
So we use predominantly nickel and stainless steel materials. The highest lead time items we've had on in the past are simple things like back pressure regulators. Often, when we do the prototyping, it's with things like bipolar plates and frames. Those are very high lead time items. But as you start to figure out what you want to look like, you can do pretty large scale manufacturing, stamping of bipolar plates and die casting of end frames. So we'd call that probably the biggest supply chain issue, but it's something we know how to resolve as we scale up.
And you already tested all the individual different parts, right? No, it's more a matter of assembling everything in a unit, right?
So this unit here, they're like mini systems. They run as our test stations in the laboratory. We built them from scratch by hand. We are also working with Fluor in Houston on an even larger balance of plant. So basically what you see on the left here. So that'll have extra validation that occurs that you would expect for components that are built for industrial use.
Thank you.
Hi, hello. I wanted to ask, so you went over at a point on the temperature and on the different systems that operate at different temperature. Can you repeat what is it exactly your value proposition here?
Yeah, so basically it's really having the best of both worlds. The CapEx advantages of known technologies today like alkaline, where they use low-cost materials, but the OpEx advantages of solid oxide technology, which has had a very hard time scaling up and entering industry. And furthermore, those are very small stacks and units. So for us, it's really to do what alkaline has done from a scalability point of view, put these units on site and be able to give customers that large electricity savings that you would expect.
Okay. Okay, thank you.
While we wait for the next question, to be clear, so we, like the prior slide, will be at 35 kilowatt hours per kilogram, which we are already hitting. So
yeah.
Okay. Any question?
One very last question. So once you have these solutions scaled, what's the target hydrogen cost and stack efficiency for your technology?
Yeah, stack efficiency will be in the mid to upper 80s from a lower heating value point of view. So you're talking about 35 kilowatt hours per kilogram, directly converts. So yeah. What was the second part of the question?
Hydrogen cost.
Oh, pick your favorite numbers. So it depends on which geography you're in. But yeah, just take your electricity price, multiply that by 35 kilowatt hours per kilogram. And then CapEx at high scale, high automation, where the labor is pulled out, you're at about 10 to 15 cents per kilogram. And then add in some of your other costs from like taxes and things like that. So you can kind of pick your favorite numbers there.
Okay, got it.
Okay, so we ran out of time. Thanks a lot, Chad and Ignacio, for the presentation and answering the questions. We'll let you know the results in the next few weeks, okay?
Sounds good.
Great, thank you.
Thanks for having us.
Thank you.
Bye.
Bye.
Bye. Okay, so we have two more startups. The next one was supposed to be Leaf, but we're going to have LAVO. They were supposed to join this morning. We managed to bring them here in this slot. So now it's LAVO who is joining.
Hello, hi everyone. It's Amer here from
Amer,
LAVO.
exactly.
Yeah.
Hi, welcome, Amer. Okay, so we are here with EDP and we are ready to hear your pitch. You can share your screen and start pitching. You have 4 minutes. Yeah, we can see it.
Okay, thank you. Hello, hi everyone. My name is Amer Rothwar. I'm with LAVO Hydrogen Storage Technology. We are based in Sydney, Australia. I'm director for APAC and government relations. So as the name says, we store hydrogen in solid state technology, and I will go briefly into the applications. So we believe that LAVO has solved some major problems in hydrogen storage, hydrogen transport, and safety. And we have achieved this by storing our patented hydrogen into our patented alloy. And the metal hydride basically absorbs hydrogen. It acts like a sponge, and the spaces between the hydrogen will actually absorb the hydrogen molecules, and we have achieved 15 times higher storage capacity as compared to the compressed hydrogen at the same pressure. So this is a general comparison. As compared to the compressed hydrogen, we store hydrogen at 30 bar pressure. We operate at ambient temperature, unlike liquefied hydrogen, which operates at or is stored at minus 253 degrees Celsius. Our storage is not toxic and does not require a lot of energy like synthesis and cracking, unlike ammonia. And we can easily transport our hydrogen using commercial container cargo ships. We do not need to build these special ships, and we do not need a large plant and infrastructure to make hydrogen and to store it. So LAVO started in 2009, and we have now got 14 IPs on our metal hydride and design. We have a complete modular system that I will show in a minute. And we have just closed our Series A funding at 37 million Australian dollars. And last year, we initiated an entity in Saudi Arabia. So we are now having business in Saudi Arabia. This year, we have registered LAVO in Japan, in Tokyo. And we are looking to raise a Series B, 25 million Australian dollars to conduct further operations. Today, I'm going to discuss 4 key areas where we have found success, and we believe this is going to be the game changer. Number 1 is the telecommunication towers. How the telecom industry is under heavy pressure to reduce their carbon footprint. So we are helping them, and I'll show in a minute how we do that. Number 2 is the hydrogen safe and compact storage. 3 is the long duration energy storage for grid scale energy arbitrage and long duration energy storage that cannot be achieved by the lithium-ion batteries alone. And the 4th is the safe, low-cost hydrogen production and transport. So this is an example we are doing with Vodacom in South Africa, where we're replacing diesel generator sets with our system. So the image you see here are the pressure vessels of LAVO metal hydride. So hydrogen is stored in these pressure vessels. And then we have this complete system which replaces the diesel genset and reduces the size of the battery, because telecom systems are all DC operated. So this actually helps a lot in the decarbonization, stability, and clean power generation, hydrogen generation on site, and supporting the DC systems on site. So, and it has its own energy management system. It's a modular design, safe, and easy to install at any telecom site. Then we have this, as I mentioned, large hydrogen storage tanks. So we are replacing, this is a case in Germany, where we are going to replace a large hydrogen compressed tank, which is, and going to make it 14 times smaller using our metal hydride, storing the same amount of hydrogen. So this is happening as we speak, replacing the compressed hydrogen storage with metal hydride storage tanks. This application is regarding grid stability, the grid scale to store and save excess PV arrays, energy coming from the PVs into the to run the electrolyzer and to store as hydrogen, and then sell the power when the energy cost is high in the market, the so-called energy arbitrage, or save it for the grid stability at a later stage. So we are already doing this, these projects. The last one here is about the hydrogen transport. So the container we see here is actually, we're shipping this, working with Marubeni Corporation of Japan from South Australia to Indonesia. So these has the pressure vessels inside, which can contain up to 400 kilograms of hydrogen in a 20-foot container. And we've just received an ISO certification that this is the first case in the world where it will be put on a normal cargo container ships and sent to a country where Australia is exporting the green hydrogen in the simplest and easiest way possible that the hydrogen can be exported. Yeah, this are the main applications of our metal hydride. And we look forward to hearing more and working with the teams here. Thank you very much.
Thank you. Thank you, Ahmed, for the presentation. So now let's go for the Q&A. Go ahead, Pedro.
Thank you for your presentation. I'm a believer on metal hydrides. I just think it has not done the breakthrough yet. We have seen similar companies, and my question is always, in terms of energy spent per kilogram of hydrogen stored, because you need to provide heat in order to retrieve the hydrogen again, right? Is it already competitive with compressed hydrogen or not yet?
Yeah, that's the main differentiator. Our metal hydride actually does not need heat management. The behavior of the metal hydride is patented to operate just like the gaseous hydrogen. But so we do not need to supply external heat to release the hydrogen. That's the key point.
How do you
It behaves
control it?
on the pressure differential.
Okay, so you just it's like the normal compressed hydrogen. You just control it with valves. You don't need to heat it.
Yeah, yes, exactly. As long as there's a certain by design, a certain output like 50, I mean, generally speaking, until 15 liters per minute flow rate, we do not need to apply external heat management.
Interesting. And do you have a value of energy needed or consumed per kilogram of hydrogen to compare with the compressed hydrogen solutions?
Yeah, we can find that out, but the main key, as I mentioned, is this is designed to saturate at 30 to 35 bar, and that is done by the machine learning process of the metal hydride composition, that it can be directly connected to the electrolyzer without any other balance of plant. So as long as the 30 bar pressure is coming from the electrolyzer, the release normally is going to be in a fuel cell if the application is power. In that sense, this is the simplest way possible, where you connect it directly to the electrolyzer without any compression or any other instruments that consume energy, and the outflow goes directly into the fuel cell, which is obviously at a controlled flow rate by a
At
flow.
what pressure can you deliver?
Yeah, the pressure, actually internal pressure on the pressure vessel starts at 30 bar. So once we open the valve, it goes directly to 10 bar, and then it stabilizes for a very long time, 2 to 3 bar at a very low pressure as required by the fuel cell. Then it can be controlled for a long duration.
Interesting. Thank you.
Thank
you. Sorry. So could you indicate the round trip efficiency of the system and also the cost per kilowatt hour?
Yeah, sure. Okay. We do not make electrolyzers, and we do not make fuel cell. We do only the metal hydride storage, and the storage efficiency of metal hydride is highest than any other, as compared to any other storage medium. There is no boil off, and so the storage efficiency is close to 95%. And the 5% that remains in there is just a hysteresis losses. So efficiency of storage in terms of storage is 95%. And there's virtually no leakage because the hydrogen is absorbed in the metal hydride. So there's virtually no losses. You can leave it for infinite time. Unlike batteries, there is no discharge. But we cannot comment on the other parts which efficiency is improving every day for electrolyzer manufacturers and for the fuel cell manufacturers.
Okay, I think we're done. Thanks a lot for your presentation, for answering the questions, Ahmed. We'll let you know the results in a few weeks, okay?
Sure, sounds good.
Thank you
very much. Thank you.
Okay, now we are going to the last startup, which is Spark Energy. And we have Julia and Tai Kim joining. Hi, Julia.
Hello. Hi, everyone.
Hi, Tai Kim. Hi, welcome.
Thank you.
We are here with DDP and we're ready to hear your pitch. So one of you can already start sharing the screen, and you have 4 minutes to pitch. So
Amazing.
Go ahead.
All right. Thank you, everyone. It's great to be here, and I know they save the best for last. So thank you for having us. I'm Julia, and I am part of Team Spark. Spark is an AI-powered project planning and research tool for developers. So developers in the room, this is for you. As we know, utility-scale clean energy projects like the ones developed by EDPR are key to transforming our grid. But data aggregation is difficult. It takes time. It's expensive to figure out the permitting, interconnection, and incentives at every location. And this can really add up in terms of soft costs. So Spark is here to bring all this information to your fingertips. At every location, every market, you just search and we bring the permitting, interconnection, all of those considerations to your fingertips instead of having to read through thousands of pages of PDFs and websites. So what better way to demonstrate our proprietary AI and functionality than through a demo? So here, Solar GPT is one example of the tools that we have using a curated database for large-scale solar and wind developers. We can ask a question about interconnection in ComEd, Illinois, and it will bring up an answer that is specific rather than just a general purpose ChatGPT answer. This is trained on industry-specific information. And so what we propose for EDP is a 3-month paid pilot together where we decide on a region and market of interest and make sure that the data is in the exact format, whether it's in terms of transmission, interconnection, and which areas are most important to EDP. In month 2, we go live together and expand in terms of regions and continue to iterate. And by the time we're ready, this is something that is fully incorporated into your workflows. And in terms of pricing, we're offering something very early access. At $40,000 a year, this would be roughly $10K for the duration of the pilot. And of course, we can discuss the details together. Spark is brought to you by a very talented and passionate team. Ty and I grew up in Brazil, 10 minutes away from each other, but we met in the US. And we worked at places like Tesla, Lucid, Apple, Microsoft. We've seen everything in software. So we know exactly what it is to build products quickly. And we're advised by some of the best and brightest advisors and experts and leaders in the solar and clean energy space. Our advantage is we can move quickly. We're currently going through Y Combinator, the top accelerator in the world, and we were one of the top 100 AI startups in the current batch. We're used to building systems that have served millions of users, and we can move very quickly. And there is an AI boom happening around the world, as you know, and Silicon Valley is at its heart and center. This movement is driven a lot by startups, not just tech giants. So you don't want to miss out on this. We would love to work with you, EDPR, and our call to action is reach out to us so that we can explore this further, and hopefully we'll see you at bootcamp.
Thank you so much, Julia, for the presentation. So who wants to start with the questions?
Hi, I have a question, but I didn't raise my hand. Thank you for your presentation, Julia. I was wondering if you have any tools or developed this tool for offshore wind, or have you thought about doing this at a later stage? Or is that just out of your scope at the moment?
Great question. Thank you. We are currently, although we're starting with solar right now, we know that EDP is really big on wind. It's just a matter of adding data. So we would work together with you and incorporate the data related to wind into our systems. No problem.
Okay. Thank you.
Of course.
Hi, Julia. Thank you for the pitch. Maybe you mentioned this, but what type of data do you need to feed in the model?
Ty, want to take that one?
Yes. So I think we support both quantitative and qualitative information. Where we shine, though, it really is qualitative information. Things that is really cumbersome to read through. So think of like 100-page PDFs, and you want to get one specific data point out of that, or just Excel files or PDFs that are like diagram or table heavy. Just anything that today is requires some manual effort to ingest that data. We can just upload it to our system and have it more in a digestible format for you guys.
Okay, thank you. And what is your track record with energy companies so far?
Say that again.
What is your track record with any energy company so far?
Yeah, so we are currently talking through a small number of early access partners. We are going through an accelerator right now. We have a few of the country's leading developers. One of them is an award-winning commercial and community solar developer based in California and currently expanding across the country. Another one is also utility scale solar and storage. And we have several in the pipeline that we are speaking with, and we are the ones who are being selective about who we work with and come live with, because we're going through an early access program right now. Instead of letting everyone off the wait list, we want to make sure that we give white glove support to all of our early customers, including potentially EDP.
Okay, interesting. Thank you. And final question on my side. How does the solution compare to existing other solutions similar to this one in the market?
Yeah, so we want to be the best at taking all this information and putting it into one place. We care a lot about project planning and search. A lot of the existing tools are focused on GIS and finding land and getting the land properties. But what we want to do really, really well is taking all of this very cumbersome data that exists publicly and use proprietary technology and the bleeding edge of AI and language models, which we can do because we have our ears to the ground in terms of the latest innovations on that front. So our differentiation is really, we're not just focused on maps and land, and we are a very focused and Silicon Valley minded and AI minded company.
Okay, interesting. Thank you very much.
Thank you.
Okay, so we ran out of time. Thank you so much, both of you, and we'll let you know the results in the next few weeks, okay? And yeah.
Yes. Thank you all so much. Appreciate
Thank
it.
you.
Bye.
Okay, we are done. It was a long days actually, but we managed to do not 39 pitches, yeah. So thank you all. I appreciate the effort and also that you kept the interest until the end. So there were always questions, always interest from your sides, and I really appreciate that. And Vasco, I don't know if you want to say something maybe about the file that needs to be filled in.
Exactly. Yes. Kind reminder for the Excel file. And
Yeah.
no, just besides that, also thank you all for joining. I think it's been very interesting. I think we had a good cohort of startups, and it's going to be interesting to see the ones that we will take to the bootcamp. I think we already have some very good candidates for that. Yeah, I think we'll speak to each of the teams individually over the next week. But in the meantime, please tell us the ones which you'd like to have follow-up meetings with, and we'll schedule them for next week or the next one afterwards. So yeah, thank you very much, everyone, for these 2 days.
Thank you. Bye.
Thank you.
Okay.
Bye-bye.
Thank you. Congrats.
Thank you. Bye-bye.
Bye.